Hello guys and welcome to today's session. Today we are going to demystify and understand the working of SCEP and NDES with Microsoft Intune. So this is what we have in the agenda. First, we are going to do a background of SCEP. We are going to understand what exactly the goal is, why exactly is it needed. We'll understand the difference between SCEP and PKCS, and then we'll drill down and understand the working concept of SCEP. First, we'll do a 1,000 feet overview, and then we'll go into the intricacies and understand the detailed background flow by using the logs and the registry and all the tools that we have at our disposal. Then we'll understand the flow using block diagram. We'll take a look over the logs and registry again, and then we'll set up NDES in our on-premise and we'll refer to all the public documentation that we have. We'll also talk about the unified connector and how this differs from the previous NDES connector that we had. And then we'll do a live demo wherein we'll set up an NDES server right from scratch. Okay, so for any user to access any application, he has to traditionally go through two phases. One is the authentication phase and second is the authorization phase. Authentication phase is the phase wherein the user is entering his username and password, and this is to ensure that user can prove his authenticity. User can prove that he is the person who he claims to be, and this is traditionally used in all the applications or maybe most of the applications. There are some applications that we can use without logging in, but in wherever in an application we are logging in, that is the phase of the authentication when we are entering our username and password. If the username and password combination is correct, then the authentication is correct. Now there is another phase called authorization. So if the username and password is correct, in authorization, it's not necessary that the end user is going to get the access. He has to go through a certain conditions, and only if those conditions are met, the user gets the access. A typical example of authorization phase would be, in case of Azure World, a conditional access policy. So even if the entered username and password is correct, only if the device, let's say, is compliant to Intune, the end user will have access to the organization resources. So these are the two phases, and SCEP fits into the authentication phase. So the goal here is we are going to use a SCEP certificate to achieve a automated authentication so that the end user does not have to enter his username and password. And this is something that we have very commonly seen, especially in our real life scenarios, especially when we are authenticating to Wi-Fi. So we know that when we are connecting to Wi-Fi, there is an option of entering our username and password, but then we can always connect to Wi-Fi using a certificate, which is more secure, and there is no overhead on the end user to enter it manually, and nobody can steal your username and password if you're using a certificate, because the certificate is there in the device. So the goal here is delivering a certificate which is in our on-premise, because the certificate is going to be issued by our on-premise CA, and the CA is there in the intranet in our domain, to a device which is present anywhere in the world over the internet. Okay, the device is going to use and leverage this certificate to achieve the authentication phase. Okay, and to do all of this, we are going to use a SCEP certificate. So what exactly is SCEP? SCEP is Simple Certificate Enrollment Protocol. This is a protocol which was originally developed by Cisco, but now this is an open standard and Microsoft is using it as well when we are deploying a certificate via NDES. It's a certificate protocol used for enrollment using PKI infrastructure. It uses request and response models and uses get and post, which we are going to see later on. The SCEP certificate can be issued to a user or a device depending upon the need. And the SCEP certificate bears the user's identity. It has the private key, but the private key is not exportable. We are going to touch upon this point in detail later on. Now, the usage of a SCEP certificate. Why do we exactly need a SCEP certificate? And how does it fit into the Intune picture is what the slide is talking about. The SCEP certificate, once deployed to a device, can be used for encrypting email. It can be used for connecting to Wi-Fi, connecting to VPN. It can do a user authentication or a device authentication wherever the need may be. And it can do a server authentication as well. So we understand the need of SCEP certificate now. And the previous slide talked about why exactly is this SCEP certificate fitting into, or how exactly the SCEP certificate is fitting into Intune infrastructure. Intune can talk to a device over the internet. So Intune is fetching a certificate from your on-premise CA and delivering to this device, which is present over the internet anywhere in the world. Okay. When and why to use SCEP certificate? We can use it if we want to achieve seamless authentication. So if we don't want the end user to enter his username and password while connecting to VPN or Wi-Fi, and we want the connection to be automatic and seamless. If we want to secure the access using certificates, if we need to issue a certificate from the CA in the intranet to any mobile device present anywhere in the world, if we need more security as compared to PKCS, and if we can afford a bigger footprint. So if we have gone through the tutorial I did on PKCS, now if we compare it with SCEP, we will see that in this case, we need a lot of infrastructure and hence the bigger footprint. Let me quickly do a comparison between PKCS and SCEP before we move forward. In case of PKCS, we don't need any NDES server. We don't need to necessarily have a trusted profile, no app proxy, no public endpoint, no IIS. All of this is not needed. However, all of this is needed in case of SCEP, which we are going to see later on. In this case, the device does not talk with any other endpoint other than Intune. However, in case of SCEP, the device talks with the NDES server. PKCS has a smaller footprint. SCEP has a bigger footprint because it's having all these components. And finally, the most important difference is SCEP is more secured because in a SCEP certificate, the private key is not marked as exportable. All right, so now let's understand how does SCEP and NDES work. And I am going to use an analogy here, which we use in our daily life. So let's say that we go to a Amazon website and we want to purchase any product. Now, the way it works is we enter our credit card details or debit card details. And just when we are going to do the payment, we receive a OTP from our bank's website. Now, the bank's website is going to send the OTP to the registered mobile number or to the registered email address only. We get an OTP, we enter the same OTP in the website while we are verifying ourselves. If the OTP entered is correct, then the transaction is successful and the product is purchased. Now, exactly the same logic is used by NDES as well. So, and what we have to keep in mind is we are receiving the OTP from the bank. The person who is placing the order for the product is entering that OTP. That OTP again goes to the bank, and bank is validating whether the OTP entered by the end user is correct and whether it matches the OTP which the bank generated at the first place or not. There are a couple of other things as well, right? That like the OTP is going from the bank, the OTP has a time to live as well, as in the OTP has to be utilized within 5 minutes or whatever the time may be. After that 5 minutes, the OTP is not valid anymore. Now, exactly the same process is going to be used by NDES, which we are going to see in the next slide. So now we are going to take 1,000 feet overview into the working of NDES and SCEP, and let's take a look over the components. So initially when SCEP was designed by Cisco, it was not designed for mobile devices or Android or iOS or Windows devices, right? They had something else in mind. What they had in mind was these network devices, like let's say routers or firewalls or all the network devices which needed a certificate. So in this diagram, we have the network devices on the left hand side, which are there on the internet. We have this SCEP server, we have the CA which is going to issue the certificate, and we have over here the network admin. Now this SCEP server over here, you can see it has got two endpoints. One is the blue endpoint and one is the red endpoint. So think of this red endpoint as the endpoint which is trusted and accessible on the intranet, and the blue endpoint as the endpoint which is not trusted and publicly accessible. So the way this works is only the devices which are there in the intranet can reach out to the red endpoint of the SCEP server, and any device over the internet can reach out to the blue endpoint. Now let's take a look over the working. The red endpoint issues a OTP. Now this OTP is equivalent to our bank server originating an OTP when we were placing an order in the Amazon website. So this red endpoint is generating a OTP, and this OTP is given to the network admin. So now the OTP is present with the network admin as well. Now what the network admin does is he goes to the firewall or the network router, he logs in over there and he enters the OTP over there. Now he makes a connection to the blue endpoint, which is unauthenticated and to which anybody can reach out using the URL of the blue endpoint. So the network admin got the challenge password or the OTP. He logged into the firewall or the Wi-Fi, and then he made a connection to the blue endpoint of the SCEP server. And when he made a connection requesting for a certificate. So the admin now is going to make a request. And in this request, he is going to provide the challenge password or the OTP. Just like in our example of placing an order via Amazon, when we are placing the order, the OTP that we received, we are entering it in the Amazon website, and the request then goes to the bank server and the bank server is going to compare. So at this point, the SCEP server has received a request from this firewall or whatever the endpoint may be, and it has received the OTP. Now the SCEP server is going to make a comparison and it's going to compare whether the OTP that it generated initially matches with the OTP that the SCEP server's public endpoint has right now received. If these two match, and whether it also checks the time to live as well. So let's say that this was uh, generated at 1:05 p.m. So this password has a time to live of 5 minutes. So within those 5 minutes, it has to receive this password again. Now the SCEP server has made a comparison between the received password and the generated password. If both match, then the SCEP server is going to go to the CA. The CA is going to issue a certificate, which it is going to send back to the SCEP server. And now the SCEP server is going to transfer that certificate to the device. So this exactly is the working 1,000 feet overview of how exactly SCEP or NDES works. The SCEP's one endpoint of SCEP is what is generating the password or the OTP, which is being sent, which is being given to the network administrator. Network administrator is taking it, logging into a network endpoint manually, and then from there it is making a connection to the public endpoint of the SCEP, and it is requesting for a certificate. While it is requesting for the certificate, it has to prove its authenticity. So in order to do that, it is providing the OTP or the challenge. SCEP is making sure that both match each other, and if it is matching, then it's going to the CA, fetching a certificate on behalf of the user, delivering it back to the device. Exactly what a gateway or Amazon website or Flipkart website is doing. So what are the components involved here? First is the SCEP URL. So the SCEP URL is the endpoint of this blue address. So the device, the firewall over here is reaching out to the SCEP server and requesting for a certificate, right? So how does it reach out to the SCEP server? It reaches out to the blue endpoint of the SCEP server using a URL. So think of URL as the URL to access this blue endpoint. The next is the SCEP shared secret or the OTP, which it generated to begin with, which was given to the network admin, which was used by the network device, which was provided again by the network device, and the same secret or the OTP which the SCEP used to match. Okay. And then the last request is the SCEP signing request or a CSR. So CSR is the request over here which the device is sending to the SCEP. So over here you see that the device is sending the OTP, right? So it is not just the OTP that the device sends. Think of it like the device is creating a packet, and that packet is containing the OTP, and the packet is containing some other things as well, which we will take a look over later. So this packet is known as CSR or certificate signing request. Okay, so CSR is the request that the device is sending to the SCEP URL or the public endpoint, and the CSR is containing the OTP or the SCEP shared secret or the challenge password. Now let's understand this. So this is what SCEP was used for. SCEP and NDES was used for when this protocol was developed by Cisco. Now let's see how SCEP and NDES is used with Intune. So now we see we have similar components, but over on the left hand side, you see the components have changed. So right now we don't have Wi-Fi routers or firewalls, but we have Android, iOS, Windows, or a Linux device which is enrolled to Intune. On the right hand side, we have the SCEP server, which has a public endpoint and a private endpoint. We have the CA and we have the Intune service. So the Intune service knows the SCEP server and the SCEP server knows the Intune service. So there is this dotted line over here. And how did this dotted line get established? This dotted line got established because in the SCEP server or in the NDES server, we installed a connector or the unified Intune connector, and we logged into the Intune connector using our global admin or Intune admin credentials from our tenant. So there is a communication happening between the SCEP server and the Intune service. Now, keeping this background in mind and keeping the previous diagram that we saw in the mind and keeping in mind the analogy that we used for payment from Amazon, let's understand the flow. Now, the SCEP server again has two endpoints. One is the public endpoint, which is unauthenticated, which is of blue color, and one is the authenticated endpoint, which is generating the password or the OTP. So the SCEP server again generates the OTP or the password and it sends it to the Intune service. The SCEP server sends it to the Intune service via the unified Intune connector, due to which the Intune service and the SCEP server can talk with each other. So now you see the Intune service has received the OTP or the challenge. Now the Intune service is in the Intune service, we create a SCEP profile, which is just like a device configuration profile or a MDM policy. The Intune service is now going to deploy that policy to the end device. So now we see that the MDM policy is deployed to the device. That MDM policy is going to contain what? So the MDM policy over here contains everything that was there in the SCEP profile, which was created by the admin, which contains the SCEP server's URL, which is the URL over here of the blue endpoint, and it also contains the OTP. So the Intune service sends this MDM policy to the end device, which is enrolled to Intune. So the device takes a look over the MDM policy once it receives it, and from there it fetches the SCEP server's URL. Now the SCEP server's URL is the public endpoint of the SCEP server, the blue, the unauthenticated side. So the device now in the next step is going to extract the SCEP server's URL. It already has the challenge password, so it's going to make a connection to the blue endpoint of the SCEP server, and it's going to provide the SCEP challenge password to the SCEP server. Now again, the SCEP server is going to validate the OTP or the challenge. It's going to compare the password that was generated by it versus the password that it has just received, and it's going to compare the time to live and few other authentication, which we'll take a look over later. Once that happens, the SCEP server is now going to connect to the CA. The CA is again going to do some authentication, which we are going to take a look over later. It's going to issue a certificate, send it back to the SCEP server, and then the SCEP server is going to deploy the certificate back to the device. So this is a 1,000 feet overview of how working of SCEP and NDES happens with Intune. Now we are going to take a look into the details of how exactly this flow is working by tracing the logs and the registry at each point. So this was a simplified diagram. Now let's take a look over a little unsimplified diagram, which is this one. Now I've got three diagrams. The first diagram explains the first 5 steps. The second diagram will again explain 5 steps, and the third diagram will again explain 5 steps. So in around 14 or 15 steps, I have broken down the exact flow that is happening in the backend while deploying a SCEP certificate using NDES from Intune to a device present anywhere over the internet. Okay, so the first step marked here as step 1 is wherein the Intune admin goes to the portal and creates a SCEP profile, and he assigns it to a user group or a device group. Now let's understand what's happening behind the scenes. The admin creates and assigns a SCEP profile. This is the very first step in the flow, which has to be carried out by the admin. Once the SCEP profile has been assigned, Intune reaches out to Azure and identifies the effective applicable users. It then fetches the common name of the members. It also evaluates the group association, making sure that the SCEP and the trusted root profile are deployed to the exact same group and not nested groups. Now, this is an important point. So let's say that the trusted root profile is assigned to a group called A. Make sure that the SCEP profile is also assigned to the same group called A and not some nested groups. Because in my experience, I've seen a lot of issues wherein nesting causes issues with SCEP deployment. So that is exactly what is happening in step number 1, wherein the admin is creating and assigning a SCEP profile in the Intune portal. Intune is reaching out to the Azure at the backend, and it's doing the evaluation of the group to which the profile needs to be deployed. Now in step 2, after Intune has done the effective group membership evaluation, it reaches out to the NDES server. Now, how does it reach out to the NDES server? How does the Intune service know where the NDES server is? Because the NDES server is present in the on-premise, right? In the NDES server, we installed something called the Unified Intune Connector, and we logged into the Intune Connector using a global admin credential from our Intune tenant. Now, once that was done, Intune service now knows where the NDES server for this tenant is. And that is how Intune knows how to reach out to the NDES server in step 2. So now the Intune service is going to reach out to the NDES server and request for a challenge generation. It's going to do the challenge generation. So this is the step 2. Intune service reaches out to the NDES server via the Intune connector and requests for the challenge password. Now the NDES server is going to generate a unique challenge per user or per device. The challenge is generated by referencing a virtual app which is there in the IIS, and it is going to return the challenge password and the thumbprint of the issuing CA and a timestamp. Timestamp is important because, as we have seen in case of Amazon as well, in our analogy, there is a time to live for the password. And that is exactly what is happening over here. It's returning the challenge password, and it's returning the timestamp. This is equivalent to manually generating a challenge password as well. So if we go to the NDES URL, we can manually generate a challenge password as well, wherein it shows this is the challenge password and this is the thumbprint of the certificate. Now, in this case, this is happening automatically, but this can be done manually as well. So before Intune was there and before Intune connector was there and all this was there, we have already seen how this happened in our very first diagram, right? In the very first diagram, which we saw over here, in this diagram, the network admin was generating a challenge password from the red side of the SCEP server manually, right? And he was taking it. Or maybe the CA admin was generating it manually and then he was giving it to the network admin. But in this case, the generation happens automatically when the NDES server requests a when the NDES server gets a request. That is what is happening in the second flow. And at this point, if we take a Wireshark trace from the NDES server, we will be able to see the challenge generation in the NDES server as well. So like in this case, we see that the enrollment challenge password is this 5ED ending with AE. Now, if you take a Wireshark trace, you can see 5ED ending with AE. This is the challenge password that the NDES server is generating. Okay. Now the communication that is happening between the Intune service and the NDES server at this point, this is encrypted using the Microsoft Intune import PFX connector certificate. Now, if you go into the NDES server at this point of time and open the MMC, you will see that there is a certificate present over here issued by Microsoft Intune import PFX connector. How did this certificate get generated and when did this certificate come into the Intune in the NDES server? Well, when we logged into the unified connector using our global admin credential, that is when Intune generated a certificate and deployed it to this NDES server. So this certificate is used for encrypting the communication that is happening between the Intune service and the NDES server. So this certificate was generated and issued when the admin did the setup of the unified connector in the NDES server, and it was signed into the same. Okay, going back to the diagram, the admin has created the profile, the effective membership valuation was done. Intune service reached out to the NDES server via the Intune connector. The NDES server generated a password or the OTP from the pool that was there in the IIS, and now the NDES server is going to send that OTP to the Intune service. The NDES server sends the challenge password, the thumbprint of the issuing CA, and the timestamp back to the Intune service. Okay. Now in step 4, let's see what happens. Now Intune service has got the challenge password for a specific user or for a specific device generated by the NDES server. Now Intune service is going to deploy a SCEP profile to the user or to the device. Now this SCEP profile was already created by the Intune admin in the portal and it was deployed to the end user. So this SCEP profile, let's call that P1, is now going to be deployed to the end device. What does this profile P1 contain? Now this P1 profile contains everything that was configured in the SCEP profile when the admin created it. So when you create a SCEP profile, you have to provide a lot of information, right? Like the subject name, the subject alternative name, etc., etc., and it also contains the SCEP server URL. Okay, so the device receives this profile P1 which contains the SCEP server URL, a lot of other information, and it contains the password which was generated in step 3. So now let's take a look over the step 4. So in step 4, the challenge information is now injected into the SCEP profile or the payload and is deployed to the device. The SCEP payload contains all the information configured by the admin in the SCEP profile, including the SCEP proxy URL. Now the device receives the SCEP payload and the challenge password. Now we can track all of this. So in the step 4, we are saying that the device is receiving the SCEP profile. How do we prove it? At this point, if you run the SyncML tool, which is there by Oliver Kiesselbach, you can see all the communication that is happening between the Intune service and the device. And you can see that the device at this point is receiving the SCEP profile and what exactly that SCEP profile contains. So over here, you can see that the device has received a SCEP profile as a part of the MDM session. It contains the server URL or the SCEP server URL, which is this, which was there in the profile as well. And it receives the challenge password as well. So this is the challenge password which was generated by the NDES server and given to the Intune service, which in turn is deployed to the device by the Intune service along with the SCEP profile. And over here, you can see this is the encoded challenge. If you decode it, you will be able to see the exact challenge and match it with what was there in the Wireshark trace in the NDES server as well. Now there are other information as well in the policy that is deployed to the device. So this is the challenge password. This is the SCEP URL. Now there is this EKU as well, which and this is the same EKU which was selected in the SCEP profile. Now, whatever hash algorithm we have selected in the profile, we see over here as well. We see the CA thumbprint. Now, if we remember when the NDES server was sending the challenge password to the Intune service, it provided the CA thumbprint and the time as well, and it contains the subject alternative name, the validity period of the certificate, etc. Now let's take a look over the attribute that were configured in the profile by the admin. So the admin in the certificate validity period had selected 6 months. That is exactly what we see in the syncml trace as well when it has received the policy. Over here you can see that the data is 6, and over here you see months, and this is the validity period. We see the key usage is digital signature. The key size bits is 2048. The hash algorithm is SHA-1 and SHA-2. The extended key usage is client authentication with this as set at as the object identifier, and this is the URL, and this is the renewal threshold. And all this information is going to be there in the syncml trace when we are receiving the profile from the Intune service. So now coming back to the diagram, we have seen the step 4 wherein the device has received the profile P1, which contained everything that was configured in the profile, and in addition it contains the challenge password as well. Now let's see step 5. In the step 5, what device is going to do in this in the profile, there was the SCEP URL, right? So the device is going to make a connection to that SCEP URL, and that URL is actually of the Azure app proxy or web application proxy, whatever proxy there may be, which is going to forward the request to the IIS of the NDES server. So the device now establishes a connection to the URL and does something called a get CA caps request. So coming over here in the step 5, you see that the device is generating and sending something called a get CA caps request. So the device actually does two get requests. One is the get CA caps and one is the get CA cert. We are going to take a look over this later. But first, let's take a look over the get CA caps request. So the device generates something called a get CA caps request and sends it to the SCEP URL. Where did it get the URL from? It got the URL when the profile was delivered by the Intune service to the device. Now, this request is going to be directed to the URL, which the device received as a part of the SCEP payload. The request can be tracked in the company portal log in the device as well as in the IIS log at the device end. So as I said, the device is generating a get CA cap request and sending it to the IIS of the NDES server, right? So where do we track it from? We can track it from here when the device is generating the get CA cap request, and we can track it from here as well when the device has successfully sent the get CA caps request to the IIS of the NDES server. Okay, now let's understand what exactly is this get CA caps. Now, caps stand in this case stands for capability. We are getting the capability of the CA, and hence the verbiage get CA caps. So over here, what we are looking to do is the end device is requesting for a certificate from the NDES server, and the certificate is going to be used by the end device for authenticating to, let's say, Wi-Fi or VPN, right? So the end device needs a certificate from the CA via the NDES, and that certificate needs to support a specific encryption model as per the profile. So the device in this case is reaching out to the CA via the NDES and checking whether the CA is even capable of issuing such a certificate or not. Hence, in other words, the device is checking the capabilities of the CA, and it is checking whether the CA can issue a certificate with a specific encryption model which is needed by the device as per the SCEP profile. So the get CA caps message allows clients to query which functionality is available from the CA. The response for a get CA caps message is a list of CA's capabilities in plain text. So there are many encryption models that the CA can support, like it can support AES or DES, or it might support SHA-1, or it might support SHA-256, SHA-512, etc. So the device is reaching out to the CA and asking for its capabilities. Now, this is logged, as I said, in both the places. It is logged in the device when it is generating the request for get CA caps, and it is logged in the IIS of the NDES when it receives it. So this is the log from the company portal in the Android device, and you can see over here it says that sending get CA caps request. Later on, we will see it does the same thing for get CA cert as well. But first, for get CA caps, you can see it is sending the get CA caps request to the same endpoint. And over here, you can see this is the endpoint. Now, when this request is generated from an iOS device, you can track that from the Xcode logs in the iOS device as well. So over here, you can see that it is performing a URL request for get CA cert and the same thing for get CA caps. Now coming back to our diagram, in the step 5, we saw that the device generated the get CA caps request, which was sent to the NDES server via the proxy. Okay. Now in step 6, the NDES server receives the request, and the NDES server is going to respond back to the device and tell the device that, okay, you know what? These are the capabilities of the CA server. So in step 6, the get CA caps request is received by the NDES server, and the NDES server responds to it. The app proxy has forwarded the request to the NDES server. The NDES server has received the request, which is logged in the IIS. The IIS is the logs in the IIS are there in the UTC, so you might have to convert it to the local time if you are tracking it. Now let's take a look over the IIS logs. So these are the IIS logs from the NDES server. Now, when we are looking at the IIS logs, you can see that when the iOS device did a get CA caps or get CA cert request, this was the log that was generated. When an Android device did it, this was the log that was generated. When a Windows device did it, this was the log that was generated. And you can also do it from a normal browser. If you do it from the normal browser, this is the log that was generated. Now, there are two things to keep in mind over here. First is, in the log over here, you will be able to see get CA cert or get CA caps both. So over here, you see get CA caps. After get CA caps, it will do get CA cert. Now, in this request, you don't see the device ID of the iOS device. So this is something that we have to keep in mind. So when a device is sending a get CA caps request to the NDES server via the proxy, it is not going to send its device ID. So the device ID is not logged. The only thing that we can identify while looking at the IIS log is the operating system of the device from which the request has come. So in the get CA cert or get CA caps request, if you see something as Darwin, then Darwin signifies that the request has come from a iOS device or a macOS device. If it's coming from a Android device, then you will see something called Dalvik, and you will see the Android word mentioned as well as the operating system version. So you will see Android and So you will see Android and Dalvik over here. If it is coming from Windows, then you will see the word Win32 as well as the version of Windows and the release version as well. So that is what we are seeing in case of Windows. And if it is coming from a normal browser, you will see the words like Chrome or Safari or Edge or stuff like that. So this is how the log at the IIS end is going to look like. And these last two steps are something that we can repro at our browser as well. So this is the get CA caps and get CA cert request. So if I were to go to a browser and this is my NDES URL, we are going to set this all up in our demo as well. And let me open a new tab. And over here, I am going to generate a get CA caps request. This is the same request that we saw in the company portal logs from the device, which the device was doing. So if I do that, press enter, I'm going to get a response from the NDES server, which tells me about the CA capabilities. So for this, obviously the NDES server needs to be up and online, because just like the NDES server was responding to the device, right now it's responding to the request from my browser. And you can see these are the CA's capabilities. So this is how to generate a CA caps request from a browser. We can do the same thing and generate a CA cert request as well. So if I open a new tab, and if I paste in the same URL which the end device was generating and do a get CA cert request and press enter, you can see that it tries to download a file. I'm not going to download it right now, but it's responding to the browser as well, the same way it would respond to a device, and it's providing me the response to the get CA cert and get CA caps request. So now switching back to our diagram. So again, a very quick recap. Until now, what has happened is the admin has created a profile, deployed it to a user group or a device group, Intune did the evaluation and reached out to the NDES server. NDES server generated a challenge password, which was sent back to the Intune service. Intune service deployed the profile, which contained the challenge password down to the device. As the device is enrolled to Intune, so that Intune service knows where the device is. The device received the profile. The profile contains the challenge password as well as the SCEP server's URL. The device is going to make a request and is going to reach out to the SCEP server's URL. The URL is that of the app proxy, which is going to forward the request to the IIS of the NDES server. The device first does a get CA caps request, that is checking the capabilities of the CA. The NDES server responds to it and provides the capabilities of the certification authority. Okay, so that concludes our first diagram. Now let's take a look over the second diagram. Now this is the second diagram, contains the same components, the Intune service, the admin, the CA, the NDES server, as well as the device. Now the step 7 is the device is going to send something called a get CA cert request to the NDES server. Now the way that request is sent is the same. The device has the URL of the NDES server. It's going to send the request to that URL of the NDES server, the SCEP URL, which is that of the Azure App Proxy. The App Proxy forwards the request to the IIS of the NDES server. This request is logged over here as well as it is logged over here. Now the IIS of the NDES server, after logging it, the NDES server is now going to respond to it in step 8. So in step 7, the device sent the request for get CA cert, and in step 8, the NDES server has responded to the get CA cert request. So this is similar to the step 5 and 6. So get CA caps and get CA cert are pretty much similar. In get CA caps, the device sent a request to check and find out the capabilities of the CA. Now, what is it doing in get CA cert? Let's take a look. So this get CA cert request is actually asking for a certificate. So it's doing a get request for the CA and it is asking for a couple of certificates. Why is this certificate being asked by the device? We are going to take a look over that later. I'm going to skip these 2 points right now and I'm going to explain this later on. So the device right now, let's just understand this. The device right now is doing a get CA cert request wherein it is asking for a couple of certificates from the CA via the NDES. And the device is planning on using these couple of certificates later on. Now, In the next step, that is step 8, the get CS cert request is received by the NDES, and the NDES is going to respond to this. Now, as I said, the NDES server has received this get CS cert request, so you can track it. The way we can track the get CS cert and get CA caps request is by enabling the capi2 logging in the NDES server. So this is something that has to be enabled. And when this is enabled, if you take a look over the capi logs, over here you can see that the get CA cert and the get CA cap request has come into the device and the device is responding to it. Now, as I said, the device is requesting for two certificates from the CA via the NDES. Now, which are these two certificates? Now, when we have installed the NDES server, there are two certificates known as the RA certificate that the NDES server receives from the CA. So right now, if you have an NDES server, once you have installed the NDES role and you have configured it, if you open up the MMC and if you go into the personal store of the local computer, you will be able to see two certificates, two RA certificates in the NDES server. Now, where did these two RA certificate came from? So in the CA, if you go, you will see that there are two certificate templates. Now these are present by default when the CA is installed and configured by the admin. One is CEP encryption and the other is Exchange Enrollment Agent offline request. Now, the first RA certificate is issued from CE encryption, and the second RA certificate is issued from Exchange Enrollment Agent template. So, without complicating it too much, think of it this way. When the NDES server was set up, the NDES server received two certificates from the CA. These two certificates are the RA certificates. The first RA certificate is received from the CEP encryption template. The second RA certificate is received from the Exchange Enrollment Agent certificate. Now, when the end device does a get CA cert request, what it is actually doing is it is asking for a copy of these two RA certificates. Why does the device need a copy of these two RA certificate? Because later on we are going to see that the device is going to generate something called a CSR, or a certificate signing request, wherein it is actually going to go to the NDES and request for a certificate. So the request for a certificate is known as a CSR. Right now, the device has reached out to the NDES and it has not requested for the client authentication certificate yet, the main certificate which it is going to use to authenticate to Wi-Fi or VPN. The device has reached out to the NDES for sure, but it has in first step asked for the get CA caps or the CS capabilities, and in the second phase it has asked for these RA certificate. But in the third phase in the diagram we are going to see that the device is actually going to ask for the client certificate which it actually needs. Now that request is known as a CSR. Now, when the end device sends that CSR to the NDES server, it encrypts that CSR using these RA certificates. And hence, these RA certificates are needed by the end device to begin with. So now these 2 points should make some sense. SCEP uses CA's certificate in order to secure the message exchange for the CSR. As a result, it is necessary to obtain a copy of the CA certificate for which the get CA cert operation is used. The response is simply the binary encoded CA certificates. So let's go back to the diagram. In step 7, the device did a get CA cert request, which went to the IIS of the NDES server. We were able to track the get CA cert request getting generated from the device by checking it in the Xcode log or by checking it in the company portal log. And in the IIS server, we were able to see that the device has successfully sent the get CA cert request, and now the NDES server has to respond to the get CA cert request. How does the NDES server respond? The NDES server responds with the two RA certificates. So the device needs those two RA certificates over here. That is why the device is doing the get CA cert. But before the NDES server sends those two certificates, the NDES server is going to validate those two RA certificates. It's going to make sure that those RA certificates are actually valid, they are not expired, which is what we are seeing over here in the CAPI logs. And it is also going to check the CRL to make sure that the revocation list is checked, to make sure that the RA certificates are not revoked or not expired. So this CAPI logs substantiates that the device is doing a verify chain and a build chain, and it is checking the RA certificate 1 and the RA certificate 2 before it is responding to the end device. So now the device has received in step 8, the device has received the two RA certificates. Now in step 9, the device is going to generate something called a CSR, and it is going to send the CSR to the NDES server. And this CSR, we are going to see what the CSR is later on, but this CSR, think of it like a packet. And the CSR is actually encrypted. And this is encrypted with the RA certificate. And that is why the device actually did the get CA cert, so that it first gets the RA certificate, and then it can use the RA certificate to encrypt the CSR and send it to the NDES server. Okay, now let's take a look over what is happening in step 9 and what exactly is a CSR. So now the device has everything it needs, so it can now generate a CSR, or a certificate enrollment request. So this CSR is the actual request from the device to the NDES, wherein this device is saying that, okay, you know what? Please reach out to the CA on my behalf and get me a certificate. Now, when the device is reaching out to the NDES and requesting for the certificate by using the CSR, it needs to provide a bunch of information in the CSR, because only then the NDES and the CA will be able to process it. Like for example, if a device tells the NDES that get me a certificate, that information is not sufficient, right? The device needs to specify that get me a certificate with this validity, with this subject name, with this subject alternative name, and this is the challenge password that I am providing so that you can authenticate me, right? I have to provide the OTP, right? Only then the NDES server is going to authenticate, and then it's going to go to the CA and provide me the certificate. So that is exactly what the CSR is. The CSR that is created, it is in accordance with the SCEP payload. So everything that was there in the SCEP profile is there in the CSR, which is the common name or the subject name, subject alternative name, the key usage, and all that information. And it also contains the challenge password, which was provided to the device as by the Intune service, as well as the other attributes. The CSR also contains the device's public key, which is going to be used by the CA later on. The device now starts a PKI operation session, and in this session, the device is going to send the CSR to the NDES server via the Azure App Proxy, and the PKI operation session is going to be kept open until the complete transaction has occurred between the device and the NDES server. Now we can track all of this in the eventware logs in a Windows device as well. So when a Windows device is going to generate a CSR, this is we see something called an event ID 306, wherein you can see that for so this is under device management enterprise diagnostic provider admin, and over here you can see the logical name of the device, and the install location is user, and some other information. And this event ID is important because this is for the generation of the CSR. Now this event log is not from the NDES server, this is from the client machine which is generating the CSR. Now, once the CSR has been generated, the device is going to send this CSR, right? As I said, it's going to encrypt it using the RA certificate, and it's going to open up a PKI operation session with the NDES server. It's going to send it. So when it sends it, then we see a event ID 36. So this in this event ID, it says that a SCEP certificate request generated successfully, and the CSR is containing a bunch of information. It's containing the EKU, it's containing the validity, everything that was there in the profile. We can see the CSR being sent by a iOS device as well in the Xcode logs, wherein it tells us that it's sending the CSR via GET. The CSR request is forwarded by the app proxy to the NDES server. The communication right now between the device and the NDES server is encrypted using the RA certificate. There were two RA certificates. One of them was issued by the CP encryption template. So the communication right now is encrypted using that certificate. The request from the device to the NDES server lands in the certserv mscep virtual application pool, which is running and which is responsible. And this is the mscep.dll. So if you go to the C drive Windows System 32 certserv mscep, over here you will be able to see this DLL, which is responsible for the entire functioning of the NDES server. Okay, now going back to the diagram. So in the step 9, we saw that the device generated the CSR and sent it to the NDES server. Now the NDES server has received the CSR. Now the NDES server is going to forward the request to something called a custom policy module. Now this custom policy module got installed and configured in the NDES server when we installed the unified Intune connector. So the NDES server sends the request to the custom policy module in the NDES, and the custom policy module in turn is going to send the request to the Intune service. And the validation of the OTP is going to be done by the Intune service. So the NDES server has generated the OTP or the challenge password, and it had sent to Intune, right? Which was deployed by Intune to the device along with the profile. So the Intune service has the challenge password. Now the Intune service is going to validate it. So right now the device has sent the OTP which needs to be validated. The OTP was sent to the NDES server. The in the OTP was there in the CSR, right? So this CSR is sent to the NDES server. The NDES server, upon receiving it, is going to forward the CSR to the policy module, and the policy module is going to forward the CSR to the Intune service. The Intune service is going to compare the password which is there in the CSR versus the password which was generated by the NDES server initially. It's going to see whether these two match or not. Okay, so now let's understand what's happening in step 10. So in step 10, the NDES server receives the CSR, and it is going to forward that to the policy module which is present in the NDES server, and it got installed when the unified connector was installed in the device. Now in step 11, the NDES policy module is going to forward the request to the Intune service for validation. So the policy module in step 11 is reaching out to the Intune service, and it is going to tell the Intune service, okay, you know what? This is the CSR I have received from this user. This CSR contains this challenge password. Can you please make sure that this is the challenge password that was originally sent to the device, and whether this challenge password is correct or not, whether the OTP is correct or not. This is equivalent to the bank server during our Amazon transaction. This is equivalent to our bank server confirming whether the OTP that I have entered in the portal of Amazon is correct or not. So the Intune service is now going to do a validation. Now the policy module in the NDES server will be able to send the request to the Intune service only if the connector is working fine right? So we need to make sure that at all times the services for the connector are fine. So you will see that in the NDES server, if you open up the services.msc, there are a lot of services running for the Intune connector. The PFX certificate connector service, the PFX create certificate connector service, the legacy connector service, the revoked certificate connector service, and the PKI certificate connector for Microsoft Intune. All of these should be running, and all of these should be set to automatic. And also the status of the connector in the Intune portal should be active at all times. So right now what has happened is the NDES server has received the CSR, and the NDES server has forwarded that request to the policy module in the server. So this is going to be logged in the NDES server's event viewer logs. So right now we are looking at the event viewer log in the NDES server. And if we go to application and services logs, Microsoft, Intune, certificate connector, operational, then over here you are going to see it says that successfully received SCEP request. So this signifies that the SCEP server or the NDES server has received the CSR. And what exactly the CSR from the device contains? Obviously, it contains the challenge, which we have already seen. It contains the hash, it contains the device ID, it contains the timestamp or the TTL, because the Intune service needs the TTL, right? Because only then it's going to match it with the TTL for when the OTP was created and make sure that not a lot of time has elapsed. It has a transaction ID, and it contains the template name. Now, there is an importance of this template name as well. We are going to see this later on. Okay, so this is logged with the event ID 4003. So coming back to our diagram here, until now we have tracked until step 11, wherein the policy module in the NDES server has received the CSR and it has forwarded the request to the Intune service. Now Intune service is going to do the validation, and it is going to check few things. It is going to check whether the user is genuine or not, whether the challenge is correct or not, whether the time to live for that challenge is correct or not, just like whether the OTP has expired or the OTP still exists. Now, these things are logged in the Intune service, but it cannot be seen by everybody. It can only be seen by somebody who has access to the Intune service by using a tool like Kushto Explorer. So a Microsoft employee can do that, wherein they can check the Intune service logs and find out what is the result of this verification of the CSR that is being done by the Intune service. So now we are going to take a look over a fresh diagram, and I promise you this is the last diagram as far as the flow of Intune is concerned. So again, the same blocks over here. We have the device, we have the NDES server, we have the CA, we have the admin. Now in step 12, you see that Intune validates the challenge, and whatever the result of that challenge is, Intune is going to respond back to the policy module and tell it that, okay, you know what, this is the result. So in step 12, you see that Intune validates the challenge and notifies the policy module in the NDES. Now, this is a log which cannot be seen by everybody. This can only be seen by someone who has access to the Intune service, by someone in Microsoft, by using some tool like Kushto Explorer. So over here, you can see it is checking the challenge of the CSR. It is checking whether the challenge password is correct or not. In this case, you can see that the challenge is true. It is checking the TTL, whether the challenge has expired or whether the challenge is still active, as in it's checking the TTL of the OTP. In this case also you see it is true, and over here it says what exactly the CSR contains. It is decoding that. It contains the key length, it contains the key usage, which is digital signature, it contains the algorithm, it contains the EKU. So Intune service right now in step 12 has made a validation and made sure that the password that was given to the device which originally was generated by the NDES server, matches with the password that the device is presenting right now while it is requesting for a certificate via the NDES from the CA and which is present in the CSR. Now, once the verification is done by the Intune service, it informs the policy module. Now, the policy module in the NDES server logs it. So we are again at the same log, the operational log at in the certificate connector. And this is the log from the event we are in the NDES server. And over here, the next log that we see is 4004 if it was successful. So over here, you see the category is SCEP verify, which is a success. So right now the Intune service has replied to the policy module in the NDES server and has said, and it has validated the CSR and the output is a success. So in event ID 4004, we see that this is the amount of time in milliseconds that has elapsed for Intune to do the validation of the CSR. And the other information as well, which was there in the CSR, which we have seen in the previous log as well. Okay, now switching back to our diagram. So in step 12, Intune validated the challenge and it notifies the policy module. We saw that in the event viewer log. Okay, so Intune by now has checked that the user is not a rogue user. It has done all the checks it needed to and it has informed the policy module. Now what is next? Next is the NDES server in the next step, that is step 13, post the validation, is going to reach out to the CA and request for a certificate. That is what the entire goal was, right? The end device wants a certificate from the CA. So once the authentication is done by the Intune service of the CSR, it informed the policy module, and now the policy module is reaching out to the CA and it is requesting for a certificate on behalf of the user or the device. So in step 13, the NDES now requests the CA for a client certificate. This request is sent by using the service or the system account which was configured in the unified connector. So when we install the connector, we specify that the connector is going to run with a system account or with a service account. So using that account, the NDES server reaches out to the CA and it requests for a certificate on behalf of the user. This request that the NDES server is sending to the CA, it is stamped using the second RA certificate, which is issued from Exchange Enrollment Agents. If you remember, there were two RA certificates, right? The first RA certificate was used to encrypt the CSR when the CSR was being sent from the device to the NDES server. Now the second RA certificate is used to stamp the request which the NDES server is sending to the CA while requesting for a certificate. But when the NDES server is going to the CA and request for a certificate, the NDES server has to specify, right, that from which template the certificate has to be issued from. Like if I just go to the CA and tell the CA that, you know what, give me a certificate, the CA does not know which template to use while creating a certificate. So the NDES server has to specify that, you know what, I need a certificate for this user for whom the CSR has already been validated by the Intune service, and I need the certificate from this template. So that name of the template is specified by the NDES server when it reaches out to the CA. And where does the NDES get the name of that template? It gets it from this registry, which is HKLM Software Microsoft Cryptography MSCEP. So if we browse to this registry, over here, there are these three entries. The admin has to pre-populate this entry. So when we are setting up the NDES, we will see that as a part of the setup, this is one thing that the admin has to do. In this registry, he has to pre-populate the name of the template which the NDES is going to use while it reaches out to the CA and requests for a certificate. The registry location determining the template from which the NDES will be requesting a certificate. Why are there three entries? That is again a different story which we'll take a look over later. For now, let's put in the name of the template in all these three entries. Okay, now switching back quickly to our diagram. Right now, the policy module has reached out to the CA, requested for a certificate. It has mentioned the name of the template from which the CA should issue the certificate. It got the name from the registry location, which we just saw. Now the CA has received the request from the NDES. So in step 14, the CA is going to do some validation, and if everything is fine, then the CA is going to issue a certificate and send it back to the device. In step 14, CA is going to check. What is it that the CA is going to check? It's going to first check that, as I said, the NDES server has reached out to the CA and has requested for a certificate. Now, who from NDES server has reached out? There is a system account or a service account which the connector is running with. So the CA is going to first check whether the service account or the system account has privileges or not to request for a certificate from the specific template it wants to. So like in this case, we have mentioned the template name NDES, which means that there would be a template in the CA named NDES. If there isn't any, then everything is going to fail. So the name over there needs to be correct. Now, if there is a template in the CA with the name NDES, the service account, the NDES service account, or the system account, whosoever is running the connector, these accounts should have the privilege to request a certificate from these templates. So again, this is a part which needs to be pre-configured by the admin, which we are going to do when we set up the NTES. So the service account or the system account should have read and enroll permission on the template which is there in the registry over here, because only if the service account or the system account has these privileges, the NDES server will be able to request for a certificate from that specific template. So it's the CA is going to check whether the service the system account has privileges or not. It's going to check whether the certificate template is published or not. So this certificate template NDES should be published, because only if a template is published, that template can issue certificates. It's going to check the validity. So when the device created the CSR, it created a validity as well, the validity for the client auth certificate which it is requesting for. And that validity was in accordance with what was there in the SCEP profile. Now, if I'm requesting a certificate of a validity of 6 months, then the template from which I am requesting the certificate should have that validity. What I mean by that is, let's say that I want a certificate from a template named NDES, and I want a certificate with a validity of 6 months. But when I go to that template in the CA and I check its validity, I see that that certificate template is capable of issuing certificates of 3 months validity only. Then in that case everything is going to fail, right? Because I am requesting for a certificate of a validity of 6 months from a template which can only issue certificates of a validity of 3 months. So I cannot request of a certificate of a validity more than what the template is capable of. I can request for less than that, but not more. So if my certificate template has a validity of 2 years, then I can request a certificate of a validity of anything less than or equal to 2 years. And this is something that I'm mentioning in the SCEP profile, which the admin is creating, which in turn is coming down to the device in form of CSR. So we have to ensure that the validity of the template is more than or equal to the validity for which the client certificate is being requested for. Once the CA has made these validation, the CA is now going to issue a certificate it's going to issue a certificate with the subject name and the subject alternative name as per the CSR, which is as per the profile that was created by the admin in the Intune portal. The CA protects the certificate package. So the CA has now issued a certificate, right? And the CA is now going to give that certificate to the NDES, and the NDES is going to give that certificate to the device. The CA is now going to protect this certificate by using the device's public key. And where did the CA receive the device's public key? The public key was there in the CSR itself. Why is it signing the package with the device's public key? It is doing that so that the certificate can only be decrypted using the private key of the device. And who has the private key? Obviously, only the device has it. So even if this certificate goes to wrong hands or man in the middle, this certificate package is signed. So only the actual device can decrypt it using its private key. Okay, so going back to the diagram. So in step 14, the CA has validated everything. We saw everything that the CA validated, and then it created the .cer, it created the certificate, and it sent the certificate back to the NDES server. The policy module received it. This CER is encrypted using the device's public key so that only this device's private key can decrypt it. In step 15, now what is going to happen? The NDES service is now going to deploy this certificate back to the device, as this certificate is now ready to be deployed. It's as I said earlier, the device actually starts a PKI operation session. So this is, think of this tunnel as a PKI operation session. So the device is communicating with the NDES server inside this tunnel. So in that PKI operation session itself, the NDES server is going to deploy this certificate to the device. So in step 15, the NDES server delivers the certificate to the device. So the certificate is sent back to the same PKI operation session that was started by the device. The PKI operation session is now closed as the certificate is now delivered, and this is going to be logged in the IIS server as well as a post or notify. Now, if we take a look over the logs in the NDES server, it is logged over there as well. So as the NDES server has received the certificate and it's deploying it to the device, it logs it in the NDES server in the operation logs under connector as well with an event ID 4006, and it tells us the subject name as well to which the certificate is deployed, as well as the thumbprint of the certificate. Now in the diagram in step 16, the policy module is going to inform the Intune service as well. The policy module has deployed the certificate to the device, but Intune right now does not know whether the device has successfully got the certificate or not. Because only when Intune knows that the device has got the certificate, it is going to mark the SCEP profile as succeeded in the Intune portal. So the policy module is now going to inform the Intune service of the successful certificate delivery in step 16. And once Intune is informed of it, if you go into the portal and if you go into the certificates blade, you can see the device name, the username, the thumbprint of the certificate as well, and the serial number, the issuer, and stuff like that. This is how the Intune service knows that what is the information of the certificate that was issued for the end device. And when NDES has informed the Intune service, it logs it as well. So now when we go to the NDES server in the same logs that is operational, we see a log with the event ID 4008, which says that successfully notified Intune of the result for SCEP request. And it tells us how much of time has elapsed in millisecond, the CA name, the transaction ID, the timestamp, the device ID, and all these information. So in step 16, policy module informed the Intune service, and it got logged in the NDES server's logs as well in the event viewer with the relevant event ID. Now, obviously, the device has received the certificate, so it's going to install it, right? So if it's a Windows device, then again right now I have switched to the event logs in the client computer. This is not from NDES, but this is from the client. In the client, if you go to the device management enterprise diagnostic provider admin logs, the MDM logs, then you will be able to see a event ID with 309. And over here, this 309 shows that the device has received the certificate from the SCEP server. It contains a unique ID. It contains the server from wherein the device has got the certificate, which is the end server's URL. And when the device installs this certificate, that is also logged with the event ID 39. So in the client device again, under the same location, it says that SCEP certificate installed successfully. So this shows that the device has received the certificate and it has installed the certificate as well. In case of iOS, we can track it in the Xcode logs, wherein it clearly tells us that the certificate was installed. Now, once the certificate is installed, the certificate has to be visible in the device, right? So where do we see that certificate? Now, in a Windows device, if it's a user certificate, we'll have to open up the MMC and we'll have to go to the certificate store. Under personal and certificates, we will be able to see the certificate. The certificate will be issued to the name as per the subject name in the profile. It will be issued by the CA with the set validity. Now we will also be able to see the certificate as issued from the CA. So if we go to the certification authority and if we go to the issued certificate tabs, over there we will be able to see this certificate which was issued to the user. Now, if we look at the requester name over here, we see that the requester name is not the end user, because the NDES server has requested for the certificate on behalf of the end user using the service account, and hence the requester name is the service account. It contains the template which was used to issue the certificate. In our case, the name of the template was NDES. It contains the common name of the user. So we have seen how we can find out whether a certificate is there in a Windows device or not. How about Android and iOS? There are different locations wherein we can find the certificate which was issued by the NDES. For Windows, we have seen it's there in the MMC under current user personal store. For iOS, for Mac OS, and for Android, let's take a look. So for Android, we will have to go to the settings and then security and then encryption and credentials, then trusted credentials, and then user credentials. So this is the certificate which was issued by the CA. The screenshot is taken from the CA, and this certificate has a thumbprint ending with F829. Now, if we go to this location in the Android device inside settings, security, encryption and credentials, trusted credentials, and then user credentials, we see the thumbprint of the certificate, which is the same, which is F829, which matches over here. So this is how we can confirm that the certificate that was issued by the CA matches with the certificate that was actually installed by the device. Now for iOS, what we'll have to do, we'll have to go to settings and then general, and then we'll have to go to device management. We'll have to click on the management profile and then go to device identity certificate. So this is the certificate that was issued ending the thumbprint ending with F1A1. And if we go into the management profile, if we click on the common name, if we go to SHA1 over here, you can see there is a certificate ending with the same thumbprint, which is F1A1. This is how we can confirm that the certificate issued by the CA matches with the certificate installed by the iOS device. The same thing is there for macOS as well. So now we are going to understand the flow by using this block diagram. As we have already seen in the flow before, the first thing that happens is that the admin creates a SCEP profile, assigns it to a user or a device. The effective group evaluation happens. The Intune service reaches out to the NDES server using the connector. The NDES server creates a challenge password and sends it back to the Intune service. The Intune now deploys the policy, which contains the SCEP profile which was created by the admin, and along with that it contains the challenge password as well. The device gets the profile, and then the first thing that the device does is get CA caps request, which it sends to the SCEP URL which it received from the profile, and it's doing that to check the CA's capabilities. The NDES server responds with CA's capabilities. Then the device does a get CA cert request in order to find the RA certificates of the CA. The NDES responds back to the device with the RA certificates. Now the device is going to generate a CSR. It's going to, the CSR is going to contain everything that was there in the SCEP profile, like the subject name, subject alternative name, uh, the URL, the validity, and the challenge password. It's going to encrypt it using one of the RA certificates. The CSR is received by the NDES server, and for validation, it is forwarded to the policy module. The policy module got installed in the NDES server when we installed the unified connector. Now, the policy module forwards the request to the Intune service for challenge validation. The Intune service validates the challenge, and then it responds back to the policy module with a success or a failure result. Now the policy module sends the request to RA, the RA passes the request to the CA or the certification authority. The CA is now going to generate the certificate after doing some checks over there. We have already seen what those checks were. And then the CA sends the certificate back to the NDES server. The NDES policy module notifies the Intune service about a successful delivery, and the NDES server deploys the certificate to the end device as well. So this is a block diagram of the flow that is happening at all the different stages, as we have seen in the logs. And we have collaborated this flow by using logs at each step as well. Now, how do we track a successful deployment? Now, the most effective way of tracking a deployment is by tracking the logs right from step one. So, well, obviously, if the device has successfully received the SCEP, obviously the step zero is going to be checking the assignment and checking the license and checking the enrollment and last check-in time of the device with the Intune service and all of that, right? I have not included that because that goes without saying. So the first thing that happens is device gets the SCEP profile. Now, if the device has received the SCEP profile, we can check it in the OMADM logs, as well as for Windows device in the real time, we can check it in the SyncML viewer. Now, after the device has got the profile, the first thing the device is going to do is it's going to do a get CA caps and get CA cert. Now we can see the get CA caps and cert request in the company portal logs, as well as from the server end, we can track it in the IIS logs as well when the devices get CA certain cabs successfully reaches the NDES server. Now the device is going to generate a CSR and send it to the NDES server. We can check the generation of the CSR in the event viewer of the Windows 10 device, Windows 10 or Windows 11 device. Now, when the NDES server receives the CSR, it's going to be logged, and then we can see it in the IIS logs as well. We can check the NDES event viewer logs as well. Then the policy module forwards the request to Intune service for challenge validation, which can also be seen in the NDES event viewer logs. Once the Intune service has done the validation, it is logged at the Intune service end. This step can only be tracked by Microsoft since they only have access to the Intune service. Once that is done, CA is going to do some checks and CA is going to issue the certificates. If it has successfully issued the certificate, we are going to see it in the issued certificate tabs in the CA. And then when the device at the end receives the certificate, it's going to log it in the event viewer as well as in the company portal or in the Xcode logs as well. And then finally, the response and everything is going to be informed to the Intune service. Therefore, we can check the dashboard. So this is how we can track and find out at which phase the flow is breaking while we are troubleshooting any issue related to NDES or SCEP. Now, block diagram for the logs, there are some logs that we got from the client side logging, like the OMADM log, as well as using the SyncML viewer tool, the company portal log, the event viewer log in case of Windows, and the Xcode logs in case of iOS. Now for NDES server side logging, there were a lot of logs that we saw in case of NDES as well. We saw the IIS logs, we saw the CAPI2 logs, as well as the NDES event viewer log, which is getting generated because of the connector, the unified connector that we have installed in the device. And then finally the CA event viewer logs in case the CA is not issuing any certificate, if any checks are failing at the CA end. So for the logs, we have seen that everything for SCEP is going to have an event ID in the range of 4000s. So we have already seen the successful logs event ID. So it starts with 4003, then 4004, then 4006, and 4008. Now, these are the successful event logs in sequence. The first one shows that the SCEP request is received by the NDES server. The second one shows that Intune service has informed the NDES server that the verification was successful. And then the third one, that is 4006, is the log which shows that a successful certificate has been issued and deployed to the device. And the last one, that is 4008, shows that the NDES server has informed the Intune service of the successful certificate delivery. So everything related to SCEP is going to be of the range between 4,000 to 4,999. If we are revoking any certificate, then that has a range of 3,000 to 3,999, and these two are for PKCS. Now, when we are looking at the logs in the connector, there is admin, operational, and debug. So the admin log does not contain a lot of information. It only contains one log per user or per device, or let's say one log per certificate. The operation log is going to contain a lot of information. So this is taken from the operational log in the certificate connectors. So it is going to contain 4 logs in case of a successful certificate deployment. If there is a failure, there might be more or less, but the admin log is only going to contain one. Debug is something that we have to enable manually, because by default it's not enabled. When we are going to do a demo, I'm going to enable it, and I'm going to show you guys all these 3 logs. Now for revocation, I just wanted to show you guys a couple of logs. So over here you can see that I was trying to revoke a certificate, and the revocation was failing because I had not enabled it in the unified connector. But I just wanted to show you guys that the event logs for revocation are in the range of 3000s. So the logs for revocation shows the same thing. First, it downloads the revocation request, and if it fails to revoke a certificate, it's going to give an error. Like in my case, it gave me an error of 3051, which was a revocation failure. Because in my case, revocation was not allowed in the connector, which has to be manually allowed. If it is allowed, then we see that it says successfully uploaded 2 revocation requests. There were 2 successes and 0 failures. And whenever there is a revocation done in the admin, so in the admin, we see only one log generated per certificate. So if a certificate is deployed, there will just be one log. If a certificate is revoked, there will just be one log. So in the admin, we don't get a lot of information. But in the operational log, we get a lot of information per certificate. So around 4 or 5 logs per certificate. So over here in the admin with the event ID 3000, we see that successfully processed revocation request. However, in the admin, you were seeing that initially I was getting 3001, because these were all the successive logs indicating failure of certificate revocation because I had not enabled it in the connector. The moment I enabled it in the connector and did a reboot of the NDES server, everything was fine. And then this log of with the event ID 3000 got generated, and I was able to revoke 2 different certificates. Now, in the operational log, you see there are a lot more events that are generated. So you see 3050, 3100, 3102, and 3102 again. So this is there in the operational log. In the admin, we saw there was only one event log. In the operational, there is a lot more. And the one with 3050 shows that we have successfully revoked a certificate. So this should help us understand the logs that we must trace while troubleshooting a SCEP issue. Now the logging for SCEP is easier as compared to what it was before. Earlier it used to be a little difficult, which we are going to see later on. But right now there is only one place in the NDES, or rather 2 places in the NDES server where we have to take a look over the logs. One is the connector log over here in the event viewer, and the second is the IIS logs. There are no other places wherein we have to take a look over logs. Earlier, there used to be a NDES plugin log, a CRP log, IIS logs, event viewer logs. It used to be all over the places. But now it is centralized in one location, that is the event viewer log. All right, so now let's talk about the components that are involved as far as a SCEP and NDES with Intune is concerned. There is a on-premise CA, which is issuing the certificates. There is a on-premise NDES via which the certificate is being installed. There is the Intune connector, which is installed in the NDES server. There is an application proxy, which is like the public or public facing endpoint of the NDES server. There is Intune as the MDM. There is the SCEP profile, which is deployed from the portal, and then there is the client device. So all the components that we are seeing listed over here is in accordance with the components that we saw in the flow over here. Okay, so now let's understand how to set up this components. We are going to very briefly take a look over this and understand how to set up SCEP and NDES in our infrastructure. I'm not going to go into very details of this because I intend on showing this firsthand live in the demo, but I just wanted to give you guys a structured approach. Now, setting up of SCEP can be broken down into three different buckets. The first bucket is setting up of the on-premise infra. There are some things that we have to do in the on-premise infra. The second step is setting up of the Azure portal. There are things that we'll have to do in the Azure portal. And the third step is things that we have to do in the Intune portal. Now, as far as setting up of the on-premise infra is concerned, there are two things that we have to set up in the on-premise infra, right? We have to set up the NDES and we have to set up the CA. Now, when we say we have to set up the CA, I'm assuming that the CA has already been, enterprise CA has already been, installed and is running. If not, then we'll have to install the CA as well. Now, once CA is installed, we are going to install the NDES role, configure it, and then we are going to do some setup in the CA. Like we are going to create the template from which the CA is going to issue the certificates and provide relevant permissions onto that template. Now let's take a look over what needs to be done as far as setting up of NDES is concerned. So first we have to install the NDES role and the relevant components. Then we have to configure the role and the relevant components. Then we'll do some configuration in the CA, and then we will do a final touch on the NDES. So the first thing is installing the role and the other components of NDES. So we can install the NDES role on a server which is joined to the domain and which can talk with the CA, which is an enterprise CA. It can be installed on a server running with Windows Server 2012 or later. And there are some things that we have to install from the server manager as well. Like we have to install ASP.NET 3.5. Now this version might change with newer version of operating system, but we have to go to the web server and set up request filtering, ASP.NET, HTTP activation, and then IIS-WMI compatibility. We have to add the user, that is, we have to add the service account to the local IIS iUser group, and we have to set up the name of the template that is going to issue the certificates in the registry of the NDES server. We have to set the SPN for the NDES service account, and we have to make sure that the RA certificates are present in the NDES server. Again, don't rush it. We are going to do all of this in the demo and we are going to reference this guide. Now we have to configure the role. Now configuring the role in the NDES server is also pretty much straightforward. We have to provide a service account, connect the NDES server to the CA so that the NDES server knows where the CA is. And then we have to make sure that IIS is also installed, and we have to make sure that the mscep.dll is also activated. Now configuring the CA, again, this is straightforward. We have to export the root certificate from the CA, which is also going to be deployed from Intune, and we just have to duplicate any user. We have to duplicate the user or the computer template and create a new template. And this new template is going to issue certificates to the end devices. And this new template should have allow private key to be exported as unchecked, because the SCEP certificate does not have the private key marked as exportable. And then we have to provide the service or the computer account privileges over the template so that it can request certificates from it. And there are a few other configuration that needs to be done. And then from the NDES, there are again there is this registry location where we have to create a dword value so that the NDES server is accepting long URLs, and we have to bind a certificate to the IIS because the end devices are going to reach out to the IIS over HTTPS, and that is pretty much it. Now we have to, now obviously in the NDES server, we have to install the connector as well. We can download the connector from the portal, and then we have to go to the NDES server, double click and install it, which is also pretty much straightforward. Now, if you are in the portal, you have to go to the certificate connectors blade, and from there you have to click over this hyperlink, which gives you an option of installing downloading a certificate connector. You go to the NDES server, right click, run it as an admin, and then you see this UI, which is going to just walk you through it. You have to click on install, configure now, next, next, next. You see that this UI pretty much looks like the Azure AD Connect UI. Earlier, this UI was not like this, but now you see there is some uniformity as far as the UI is concerned. And over here, you have to select the SCEP option. And if you want the option to revoke certificates as well, you have to select the certificate revocation option as well. This is just a one-time setup that the admin is doing on the NDES server. And then you are selecting whether you want the connector to run with a system account or a domain service account. If there is any proxy, you provide that information, and then the connector runs a prerequisite checks, make sure that all the components that are needed for the connector to run is set, and then you just have to log into the connector using a global admin credential. Make sure that this credential is global admin and has a Intune license assigned to it as well. And then when you sign into it, it says that sign in was successful, and at this point of time the device gets a certificate issued. The NDES server gets a certificate issued to it by the Intune service, and we have already seen what this certificate is during the flow. It is this certificate, Microsoft Intune Import PFX Certificate Connector, which is encrypting the communication between the Intune service and the NDES server. So this is getting issued when we are logging into the Intune connector, the unified connector, while installing it. Now, once we have logged in, over here we can see that a entry for the connector is made. It shows the timestamp. We can rename this entry as well with the name of the server. It should show active at all points. And we should make sure that the relevant service behind this connector in the NDES server is also running and started at all points. And if we want to launch this UI at a later point of time, we can go to this location and then right click and run this PFX connector UI as an admin. Now, once this on-premise setup is done, now we have to set up the Azure App Proxy, because the request from the internet cannot directly reach to the NDES server. There is a man in the middle, which is the proxy, which is accessible over the internet. So the devices reach out to that proxy, and that proxy forwards the request to the NDES server. So we have to download and install the proxy connector in one of the servers as well, which should have internet connectivity. And just like the NDES server, because the proxy is going to talk with the Azure service, just like the connector was talking with the Intune service. And we have to publish this proxy as an application in the Azure portal, which we are going to see in the demo. And when all that is done, we just have to create a SCEP profile and deploy it to the device. Now, I just want to very briefly talk about the updates in the unified connector. So this unified connector was kind of recently launched. And before that, we used to have the NDES connector. Now with the NDES connector, the logging was very different. We had a whole bunch of logs, and the tracking of everything, the tracking of the flow via the log was difficult. With the unified connector, things have become a lot easier. Right now we don't, so I'm not going to go into details of what is not needed anymore, and I'm not going to explain why it was needed earlier, just to avoid confusion. But earlier we needed to have a client authentication certificate, which we had to bind to the connector. We don't have to do that anymore. Now there is no CRP. The location of the log is changed. Now everything in the NDES server is being tracked in the event viewer logs. Earlier there were a lot of places. The setup file has also changed. Earlier the UI of the setup file was different. The registry location has changed. The flow has pretty much changed. When I say the flow has changed earlier, again, not to confuse you guys, but earlier the CSR validation was done by the NDES server itself. So we could track it by looking at the NDES server logs. However, now that has changed, and now the validation is being done by the Intune service, and hence we cannot track it unless we have access to the Intune service. The prerequisite needed for installing the connector has also changed. The folder structure has changed. The service name has changed. Again, not going into very details, but this is how it was earlier. I mean, let's say that you're installing the connector. Right now, if you're installing the connector and some component is missing, like for example, let's say that ASP.NET is missing, it will give you an option to rerun the check, and it will tell you what is missing in this format. Earlier, it had this UI. So now you can see that the UI has changed, and as I said, this UI looks a lot like the Azure AD Connect. Earlier, the folder structure was also different. We had C drive program files, Microsoft Intune, and then Index connector SVC, and then inside of that logs and logs. Now we have C drive program files, Microsoft Intune, and then PFX certificate connector. That is the name of the folder, and inside of that we have these subfolders. And the one that we are concerned right now is the SCEP one. Now earlier, as you can see, there were a whole bunch of logs. Over here, you can see that there was this policy module NDES plugin log. There was this CRP log, NDES connector log. And over here, you can see one important thing, that is the verify. So earlier, as I said, the verification of the CSR was being done by the NDES server itself. So you could see the phases of verification. It would verify three things. First is it would verify the challenge. It would verify whether the user is the actual user or not, and it would verify the time to live of the challenge, or the OTP, the time to live for the OTP. So we would see the validation phase one started, phase one finished, phase two started, phase two finished, phase three started, phase three finished, and then notify finished. So this is actually the validation of the CSR that is happening in the NDES server. However, this is the old flow when we had the old connector. With the newer connector, now as we have already seen the flow, the validation of the CSR is being done by the Intune service. So earlier this step 12 did not used to happen. The policy module would not reach out to the Intune service. Like right now, policy module is reaching out to the Intune service. Intune service is doing the validation of the challenge password and then informing back the policy module. Earlier, what used to happen was there was something called a CRP, or certificate registration point, which was installed in the NDES server, and that would do the validation in the NDES server as well. So think of it this way: earlier the NDES server would do the validation. Now the act of doing validation of the challenge is offloaded to the Intune service. Intune service is doing the validation and reporting back to the policy module. Again, did not wish to confuse, but just wanted to let you know that this step 12 that is happening right now, this did not used to happen before. So earlier we would in the CRP log see the phases of validation. Now, since the validation is happening in the Intune service, we can only see it in the Intune service logs if we have access to. And now all the logging is right now. Earlier, like we used to have the plugin log and CRP log and disconnector SVC log in all these different location in the folder structure. Now everything is there in the event viewer. So now if we go into the event viewer under Microsoft Intune certificate connectors, the admin debug in the operation log in the event viewer is the only place that we have to look into, the other place being the IIS logs. Okay, that's pretty much it. I mean, I know this was a lot of information. I did not want to do a lot of theoretical explanation as far as the setup is concerned, because we are anyways going to see it in the demo now. But until now, I hope that we would have understood the flow that is happening, and we are going to use the same logic while we are going to troubleshoot once our setup is done. So now let's switch to the demo, and we are going to set up an NDES server and then see it's working live. Okay, for the demo, I am logged into my hypervisor, and over here you can see I have a domain controller. I have just now set up a fresh machine, named it demo NDES, and we are going to see what the status of this machine is. This is a vanilla machine, and we are going to install the NDES role and configure it. The NDES 1 and NDES 2 server are already functional, so let me just power these two down so that we can start working on our machine. Okay, all set. So now first let me go to the domain controller and show you the configuration that is present in this. So this is my domain controller, and my domain controller is my certification authority. Now it's not necessary to install certification authority in the same server as the DC, as we all know, but that is how I decided to set it up. So let me quickly open up the MMC and show you guys. Over here you can see it tells me that I have the certification authority snap-in available as well. If I just add it, finish it, and do a OK, over here I will be able to see all the templates that has been published from the CA, all the certificates that has been issued from the CA and stuff like that. So we are going to come to the CA later, CA or DC later. Right now, let me go to my NDES server, the server that we are going to make NDES. So let me power it on. Again, this is a vanilla machine. Once it powers on, I'll show you guys the configuration that is already done in it. Let me quickly open up the command prompt and then just do a host name. You can see right now we are logged into this machine named demo NDES. And this machine is joined to the domain. So that is all I have done. I have joined the demo NDES machine to the domain. The name of my domain is intune.com, and we have already seen the domain controller. Okay. The IP address of this machine is 192.168.100.7, and this machine has internet connectivity. Since we are going to install the Intune connector in this machine, it's important that the machine has internet connectivity as well. All good then. And when we open up the server manager over here, you see that no roles has been installed in this server yet. So all I have done is joined this machine to the on-premise domain. That's the only configuration that has been done in this machine. Okay, so now we can start with our configuration. The first thing that we are going to do is we are going to install the NDES role. So for that, we'll have to go to the server manager, click on add or remove roles, and then next, next, next. And then the NDES is a part of ADCS role. So we are going to select ADCS, click on add feature, then do a next, then do a next again, and a next again. And over here, instead of certification authority, we are going to select the network device enrollment service. It's going to install some other components along with it, which is fine by me. Just make sure NDES is selected and nothing else. As we already know, for the purpose of Intune, NDES and CA cannot be the same server. Hence, I have set up a fresh server. Just going to do next, next, and then install. And while this shows up, let me show you the WinVer and show you the machine. This machine is running with Windows Server 2022, but as per our documentation, you can install NDES on a server running with 2012 or later, depending upon whichever operating system is supported by Microsoft. So just going to wait for a couple of minutes, and once the installation is done, we are going to come and configure it. And while the configuration happens, let me quickly show you guys the deck. So right now we have to first set up the on-premise infra. This is what we are doing. And then we will do the step 2, that is setting up of the Azure. And then we'll do step 3, that is deploying the SCEP certificate from the portal. So the first part was setting up of the on-premise infra. And in that, the first one was installing the role and the other component. So that's what we are doing over here. We are installing the role and the other component. So we have a Windows Server. I mean, it needs to be 2012 or later. I have a latest one, so I'm making use of that. And we are installing the NDES role. And while we install that, some of these components are going to be automatically installed. Whichever is not automatically installed, we are going to install that manually. So this installation is going. While this installation happens, let me open up the MMC and show you guys what's going on over here. So let me add certificates for user account as well as computer account. In the current user under personal, nothing is there as it shouldn't be. But however, under the computer store under personal, right now you see that nothing is there under in the computer store under personal, right? Later on, we are going to see how this is going to change. Okay, all good. So let's do a no. The configuration is done, installation is succeeded. We can just click on close. And now let's configure this. So for configuration, just open up this exclamation mark and then click on configure this. When you're configuring it over here, you have to provide an account which has enterprise, which is a part of the enterprise admin group. So right now this account is a part of the enterprise admin group. I'm just going to click on next, and over here all the other options are grayed out because this is the option that I selected when I was installing the role. So I'm just going to click on NDES and then do a next. And now over here I have to provide a service account. Now this service account needs to be a part of the local IAS users group. So I'm going to quickly open up computermanagement.msc and add my service account over there because right now it's not added. So I'm just going to go to groups, ISI users, and then do an add. And then my account is NDES SVC. All right, it's added, apply, okay. Just close this and then providing the same account over here, which is NDES SVC and its password. Just doing a okay over here, it's going to make a check to make sure that the account is part of the local group. It is. Just going to do a next and then click on select this, next. And this is the part wherein my NDES server gets a RA certificate. So when we saw the MMC in the store, there were no certificates, right? But when I'm configuring the role, now my NDES server is going to get the two RA certificates from the CA. Now in the flow, we have already seen the significance of this RA certificate, and these RA certificates, there are going to be two RA certificates, both going to be issued from two different templates from the CA. One is the exchange enrollment offline and one is the other one. So if you want, you can enter some information over here. So I can enter that. All right, I've put in the optional information and then it's going to ask me the key length over here. I'm going to stay with the default, just going to click on next, and then it's telling me a list of the information that I have chosen. Just going to click on configure. And there you go, the configuration is done. I'm just going to click on close. And now in the server manager also, you can see that there is IIS installed as a part of the configuration. So, and we already know that why IIS is needed as a part of NDES, therefore it has been installed as well. You can just open up the IIS and see the default pool that is created. So we'll have to bind a certificate in the IIS later on because IIS works on HTTPS. Over here, you can see that the default pool and the SCEP pool is also created. Looks good. All right, so far so good. Just going to minimize this. And now there are a few other components that I need to install, which are needed for NDES to function. So like for example, .NET Framework, ASP.NET, IIS6, WMI compatibility, and a few other stuff. So let me quickly make sure that all these components are also installed. These components are needed for to make sure that the Intune connector can be installed. So these are requirement of the Intune connector. So just I am going to go to manage and then add server roles again, and then go to next. So the first one is under web server, we are going to select request filtering. And then in web server application development, we have to select the ASP.NET, whichever is the latest one. So I'm just going to select both of them and select the relevant dependent features as well. And in the management tools, I have to select the IIS6 WMI compatibility. So looks good. Just going to click on next, and under the .NET features as well, I'm going to select the HTTP activation, click on the relevant features, and over here as well under WCF, I have to select HTTP activation. All right, so far everything looks good. Let's click on install and let's wait for this installation to complete. Okay, so it looks like the installation is almost done, and it says that installation succeeded on the server. It takes less than 10 minutes for this to happen. Everything is done. So first thing I'm going to do is I'm going to initiate a reboot because again, it's not compulsory at this point, but since the installation of the role is done and there are registry changes that are made with that, I'm going to initiate a reboot. Now, one thing that I want to do is in the local server, I want to turn off the IESec because when we are going to install the connector, we are going to see that IESEC is going to block a lot of pop-ups in websites. So I'm just going to set this to off, and I recommend you doing this whenever you're going to install a connector in the NDES server. All right, so let's first open up the browser and let's make sure whether the NDES URL is working fine or not. So right now I'm going to go to HTTP and not HTTPS because HTTPS is not configured in iOS yet. And then localhost search serve mscape mscape.dll. If I go over here, you see the NDES enrollment page. And you can also go to mscape_admin, and if you are in if you have the privileges, you'll be able to generate a password from there as well. But this shows that the NDES rule was successfully and correctly installed in the machine. Now let me quickly open up the MMC, and if I go to certificates, add computer account, and then finish, now we should be able to see the RA certificates in the personal store. So if I'm in the personal store over here, you can see that I am able to find two RA certificates. Okay, well and good. But these two RA certificates are not enough. I need a third certificate which needs to have server authentication in it, which I'm going to bind in the IIS. So I have to request for that certificate first, right? Now let's request for that certificate then. So I'm just going to click on the white area over here and then all task and then request new certificate. Then I'm going to click on next. At this point, the NDES server is reaching out to the CA and it's going to request for a certificate. But when we are going to request for a certificate, we have to mention, right, that from which template we want to request a certificate. So I'm going to use the computer template, which is good enough. And I'm just going to click on enroll and then finish. Just when I do that, you see that there is a certificate which has been issued by the CA to the NDES server over here, which is named demo NDES, and it has the client auth and server auth EKU in it, right? So server auth is the EKU that I actually needed. You can double click and then go to the details and go through the details over here as well. And the certification path shows that issued by the CA, issued to the NDES. So far, so good. So I have the certificate that I need to bind to the IIS. So now let me go to the IIS and bind this certificate so that I can make use of HTTPS connection. So going to expand this, going to go to sites, going to go to the default website, and on the right hand side going to click bindings. Right now you can see that HTTP is the only type which is selected with the port 80. I'm going to click on add and select HTTPS. It's going to use the default 443 port. I don't have to necessarily put in a host name. And in the SSL certificate, I have to select the SSL certificate. Right now, there is only one SSL certificate that is present in the device, therefore it shows you only one. If there were multiple, it would show you a list of those certificates, and you have to select the appropriate one from the drop down. You can look at the common name and figure out that you are looking at the right one. You can select it and then you can do a view as well. It shows you the certificate, and you can ensure that you have selected the right certificate over here. I know that I have selected the right one. Demo NDES is the right one. I'm just going to click on OK. You see that HTTPS is also now active using the port 443, and it is secured by the SSL certificate we just bound. All right, so IIS looks good. It is recommended to restart the IIS, but I'm just going to save that for later because there are some other registry changes that I have to make. So talking about registry, let's open up the registry edit real quick. Now, after NDES was installed, the relevant registry is also going to be populated. That is HKLM, software, Microsoft, and then cryptography. Now, inside cryptography, you see that there is a node called MSCEP. And this node was not there before. Just after NDES was installed and configured, the MSCEP node got created. I'm going to expand that, and over here it tells me the relevant information. It tells me the CA name. This is the common name of the CA, so looks good. And then there are some other registry values, not really relevant. And yep, pretty much looks good. All right, so the registry also looks good. Now the main thing over here is in the MSCEP folder over here, you see that there are a couple of keys, and this is the key that the NDES is going to use when it is going to go to the CA and request for a certificate. Now remember the flow again, guys. NDES is going to go to the CA and request for a certificate on behalf of the user. right? So bringing up the diagram again here real quick. So in step 13, the policy module from the NDES received from the Intune service and found out that the validation was successful. Now the NDES in step 13 is going to go to the CA and it's going to request for a certificate. Now when the NDES goes to the CA and request for a certificate, NDES has to mention, right, that which certificate template has to be used while issuing the certificate for the end user, and that information is present in this registry location. So we have to populate this registry location with the name of the template that the CA is going to use while issuing a certificate for the end user. Right now, by default, it is configured with IPsec intermediate offline. I'm not going to use this one. I'm going to create a new template, which I'm going to show you guys how to do that. And then I'm going to populate it over here. So to do that, we will have to go to the CA and create a certificate template over there. So right now, let me go to the CA. In my case, it's the same as the DC. So let me log in over here. Okay, so I'm at the CA right now, and I have gone to the certificate templates folder in the MMC under certification authority. And right now, by default, you can see all the templates that are published by the CA. And you can see these are all the default ones. There are two templates that I manually created and published for the two working NDES that I already have. Now we already know IPsec offline and CP encryption. These two were used to issue the RA certificates right now when we were logged into the NDES server and requesting for the RA certificate. And this computer template issued the SSL certificate that I just bound to the IIS in the NDES server. So right now what I'm going to do, I'm going to create a new template. So right now what are we doing? We are logged into the CA, we are creating a template and we are publishing it so that when the NDES comes to the CA and requests for a certificate, this template issues those certificates. So I'm just going to duplicate the user one. Now we have to keep in mind that the certificate that the end user needs, it needs to have the client auth EKU. So that certificate is going to have the client auth EKU only if the template from where it is coming from also has the client auth EKU. So that is why I have chosen the user template, because the user template has the client auth EKU in it. So I'm just going to right click on this and then do a manage, and then I am going to locate the user template. This is the user template. I'm just going to right click and then duplicate. So right now we are creating a new template by duplicating the user one, because we are duplicating it because we have to make some changes to it. Just click on duplicate, and then we don't have to make any changes in the compatibility tab. Everything looks good. When we go to general, we have to name this. So let's name this template. So I'm going to call this EAI NDES. Now the template name and the template display name both usually are fine, are the same. If you have put in any spaces, that space gets removed from the template name. Make sure you're not putting in any space as a recommendation. Now the validity, this is important. If your template has a validity of 1 year, the end certificate can have a validity of 1 year or less, but it cannot have a validity of more than that. So make sure that you are setting the validity over here accordingly. And over here it says that published certificate in Active Directory. You can check it or uncheck it, both work fine. However, I'm just going to uncheck the published certificate in Active Directory because I don't necessarily need it. Now the next tab is request handling. Over here I'm not going to go into the details of this, but for now let's go with the default one, that is signature and encryption. In a separate nugget, I am going to explain what happens if you select encryption or signature and encryption, or the last one. Okay. Right now, we are going to go with the default one. In this option, we are going to select allow private key to be exported. We are going to uncheck it because in a SCEP certificate, the private key is not marked as exportable, and this is what makes a SCEP certificate more secured as compared to PKCS. So it's important that you uncheck this, allow private key to be exported, and we can go with the default option which says that enroll subject without requiring any user input, because we don't want to provide any user input. Cryptography is fine. It has a minimum key size of 2048 determined by CSP. Everything looks fine over here. Key attestation is also fine. There is nothing that we have to change. Now, security is an important one. So the NDES service account or the computer account of the NDES server is going to come to the CA and request for a certificate from this template. So that service account or the computer account should have privileges to request for that certificate, right? And that is what I'm going to do over here. So let's add the NDES service account, and let's do a okay, and let's add the computer account as well. So in the object type, I'm going to click on computers and then do a okay, and then the name of the computer is demo NDES. So just going to click on okay, and the account needs to have a minimum of read and enroll privileges. So I'm just going to provide read and enroll privileges to the demo NDES computer account, as well as read and enroll privileges to the service account, and then just click on apply and OK. Now the next tab is extensions. In the application policies over here, make sure that it has client authentication EKU. In the key usage over here, it has digital signature, which is fine. Signature is proof of origin. This option needs to be unchecked if you are planning on deploying certificates to iOS or macOS devices. Superseded template, all looks good. Subject name, we have to click over here, supply in the request, and then do a OK over here. And then server and issuance requirement, we are just going to do with default. Now, let me quickly show you guys the official documentation which talks about all these steps. So this is the official documentation which we can follow: configure infrastructure to support SCEP with Intune, or this is the name of the blog, NDES and SCEP setup with Intune, a complete guide. So in this blog as well, I have mentioned all the steps with the same diagram that we saw in the setup right now, and it walks you through all the steps that we are following right now. Or you can follow the official documentation, which is also telling us the same thing. All right, so far so good. The template looks fine. There is no other changes that are have to be made. Let's quickly review everything and make sure that everything is in place. Okay, looks good. I'm just going to click on OK. Now my EAI NDES template is created. I can just close this. Now the template is created, but it is not published, right? Therefore, you don't see it over here. So I have to right click on this, and then I have to select certificate template to issue. So I am going to select the EAI NDES from here, which is here. So right now you don't see EAI NDES over here, right? But once I publish it, if I do a OK, now you see EI NDES over here. So now this certificate template is ready to issue certificates. So let me just minimize this and go back to my NDES server. Okay, now let's update the registry. So we have to update the registry with the name of the template. So let's call this EAI NDES, and we are going to update all the three registries. Now there is one more registry location wherein we have to create a couple of entries. Let me quickly go to HKLM system current control set, and then services, HTTP parameters. And over here we have to create two dword values, and this is for the max URL field length. So I'm going to explain what this is for. So let's go click on the white area, do a new, and then do a dword value. And we are going to name this max field length, and the value is going to be set to decimal, and the value is going to be 65534. And I'm going to create another dword value with the name max requests bytes. And this is also going to have the same decimal value. Make sure the value is decimal and not hexadecimal. Okay, and one last setting that has to be made. Well, not exactly one last, there are a few others as well. We have to go to the IIS and then default websites and then request filtering, and then go to edit feature settings And over here also we have to enter the same value that we added in the registry. So the maximum URL length and the query size string both are going to be 65534. All right, so the next thing that we have to do over here is install the Intune connector. So for us to install the Intune connector, let's first go to the Intune portal and download the connector from there. So let's go to endpoint.microsoft.com. Okay, and let's go to tenant administration, connectors and tokens, and then certificate connectors. Over here, you can see that all the connectors are in errored state, and that is because there are two connectors which are active, the NDES2 and NDES1, though the servers are currently powered off, and the rest are all the legacy connectors. This was just my attempt to show you guys that I had a working NDES with the older connector as well, and that is why I have not removed it. The recommendation is removing the older connectors from the portal whenever done. Now I'm just going to click on add, and there is a link over here which says that download the connector. So I'm just going to click on this hyperlink, and the Intune certificate connector exe is going to get installed, it is going to get downloaded. It is downloaded now. So let's just right click on this and then run this as an administrator. Let's do a yes. All right, so the installation is complete, doesn't take more than 30 seconds. The main thing is the configuration. So I'm just going to click on configure now. You see the UI is a lot like Azure AD Connect UI. The older UI was not this colorful. So over here, I'm going to select on SCEP and uncheck PKCS. I'm going to select a certificate revocation because at some point I might have to revoke the PKCS, sorry, the SCEP certificate. But make sure that you're selecting SCEP if you want to make use of SCEP, or PKCS if you want to make use of PKCS, right? Just clicking on next. Now over here we need to mention that the connector is going to run with the system account or the domain account. I am fine running with either. I am going to go with the default one of system account. Then just click on next. If you have any proxy, you need to provide it over here so that the NDES server can talk to the Intune service over the internet. I don't have any proxy. It's going to check the prerequisites over here, and this is the part wherein it checks everything that we installed from the server manager. So if the .NET or HTTP request filtering, or I mean anything like that is missed, this is wherein you are going to get a prompt. It says that all the prerequisite checks have passed, so I'm all good. Just going to click on next, and I have to sign in right now to the Intune connector, because right now the Intune connector does not know what is the tenant, right? There are so many tenants in Azure. This Intune connector needs to talk to my tenant, because in my tenant I'm going to deploy the Intune, the SCEP profile. So I have to log in over here. The signed in account needs to be an Intune admin or a global admin. I suggest that the admin should have Intune license assigned as well. So once it does that, I can just do a yes over here, and then the sign in is successful. Just going to click on next. It is going to restart the service for Intune connector and then enroll connector to Intune. At this point, the NDES server got a certificate from the Intune service, which is going to encrypt the communication between the Intune service and the NDES server. How do we make sure that that happened? If you open up the MMC, and if you open up the certificates again, earlier we saw that there were three certificates, two RA certificate and one SSL certificate, which we had manually requested. But now there should be one more, which is provided to the device by the Intune service, and there you go. Let me expand these. These are two RA certificates. This is the SSL certificate which we requested and bound to the IIS in the end in the server, and this is the certificate which we just received. If you double click on this, you can see that this has been issued to this GUID, and this has been issued by the Microsoft Intune import pfx connector CA. This is, you can think of it as a CA in Azure, managed and maintained by Microsoft, and then it contains a lot of information. By default, this is valid for 1 year, but this gets extended, so you don't have to worry about that. All right, looks all good. I can just close this, and the connector is also in place. Now, a very important step that we need to follow over here is, after the connector has been installed, we have to reboot the NDES server. Now, you guys won't believe I learned this the hard way. There are so many things that can go wrong if the NDES server has not been rebooted after the installation of the connector. And I've been working on this NDES setup since 4 or 5 years now, and I have seen so many crazy things happen. So I am not going to waste a lot of time before initiating a reboot, because I don't want to forget doing that. So I'm just going to reboot it. Okay, let's first open up the services.msc. So the connector services are all these. The PFX certificate, earlier it was used to call Microsoft Intune connector service, but now the name of the service has changed, as the name of the connector has also changed. We need to make sure that all these connector services are running and they are set to automatic. In my case, all the connector services are running and are set to automatic, so I have nothing to worry about. Now let's open up the same URL once again, which is HTTP localhost. And now we are expecting to see a 403 forbidden error. And this is because once the Intune connector is installed in the NDES server, now you cannot see the NDES enrollment page, because a request for enrollment is always intercepted by the Intune connector. That is what you are seeing over here. The request is intercepted and it is showing a 403 forbidden error request. This is not exactly an error. This is actually a good sign. All right. And now the same thing should work on HTTPS as well, since we have the SSL certificate in place. So let me put in HTTPS and then advanced and then continue, and you see the same thing. The same thing should work with HTTPS and the FQDN of the server, and then search serve mskip. And over here also you see that with HTTPS and the FQDN it works fine. Make sure that you are checking all these three: HTTP, HTTPS, as well as the FQDN instead of localhost. All right, so far so good. Everything looks good as of now. Now let's open up the event viewer. As we have already spoken, there are only two logs that we need to check now as far as functioning of NDES is concerned. One is in the event viewer and the other is the IIS log. Over here you see there is a node called Intune, and that is for the certificate connector. If I just expand this certificate connector, let me expand this again. There is admin and there is operational. Right now in admin, you will only see one event per successful or failure certificate generation. Operational is lot more verbose. So over here you will see that since the connector was installed, logs related to that as well. There might be few errors, which is absolutely fine. But as of now, my server is all running fine. Yeah, these you see that it's all running fine and it is all healthy. The service is also getting restarted. Okay, all good. The other thing that I'm going to do is I'm going to enable the debug log. So let me just click on this, and now you see that there is this debug log as well. Right now there is nothing in this, but when the certificate issuance and all of that happens, you will see events getting generated over here as well. But this is not present by default. It has to be enabled, just like I enabled it right now. All right, all good. So let me just go through the documentation real quick and make sure that everything that is there in the documentation has been followed. So uh, 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 let's come over here, and this section is talking about the template. We have done the template. This section is talking about granting permission to certificate revocation. We have done that as well. So let's keep going down. Um, this is a step that we have to perform. We have to run this commands in the CA. so that this is done so that we can a value can be set within the Microsoft Intune Admin Center console. I have already run this command, therefore I'm not going to run it again, but this is very simple. You just have to open up the NDES server, go to the command prompt, run this command, and then this is going to stop the service and start the service again. We have published the certificate template which is going to be used, and then we have installed the NDES role as well. These were the three registry locations. We have updated these three registry location with the name of the template as well. We were able to see the NDES enrollment page, and then we installed the Intune connector as well, which is what this is talking about. So everything looks good as of now. The only step that is pending right now is the end device cannot reach out to the NDES server, because this NDES server is present in the domain, right? And this NDES server is only discoverable over the intranet. So we need to install Azure App Proxy or Web Application Proxy or some kind of proxy, so that the end devices from the internet can reach out to the server as well. So I'm going to make use of Azure Application Proxy because, well, obviously it's free and I don't need to install any other component in my server. Just install a connector, the Azure App Proxy connector. So I am at my portal right now, and if I go into Azure Application Proxy, from here I will have an option of downloading the connector. So right now you see that I've got two connectors downloaded. Both of them are inactive. I'm going to download the connector service and then accept terms and download. This is going to download the Azure Application Proxy. I'm going to run this as an admin. This also takes less than 1 minute to install, and then we just have to quickly configure it. All right, done. You can go to the logs as well and see it if in case the installation is failing. So the app proxy is installed and we have logged into it as a global admin. So the app proxy connector in my NDES server knows where my tenant is. If I go to appwiz.cpl on the control panel, I can see that the connector is installed as well as the certificate connector for Microsoft Intune is also installed. So these are the two things that I needed to install in the server. So all good over here. Now, just installing the app proxy is not sufficient. There is some configuration also that needs to be done for the app proxy. Now, that configuration needs to be done at the portal. So let's go to the portal real quick and do that configuration. So this is my portal. So earlier you were seeing that there was NDES 1 and NDES 2, but now you see there is a demo NDES also, which is showing as active. These two servers are powered off. This is the only one that is powered on. Now let's create a connector group. Let's call this the EAI connector. And then we have to select a connector over here. I am going to select the demo ndes.intune.com. I'm just going to select that and then click on create. And then you are going to see that demo ndes.intune.com. Right now it's present inside the default connector group. But then you are going to see we are going to have three connector groups now. The first one is the EAI connector group, which contains the first NDES, then the NDES connector group, which contains the second NDES, and then the NDES 2 connector group, which contains the third NDES. Just trying to segregate it, you don't really have to do it this way, but just for parity's sake. Now let's understand the significance of this app proxy connector. You see that this Azure app proxy connector has a public IP, and this public IP is an endpoint which any device can reach over the internet, and hence we needed this public IP. Now what needs to be done next is, so the concept here is the devices are going to reach out to the app proxy or this IP address, and this app proxy has to forward all the requests to the NDES server. As the app proxy is installed in the NDES server, the app proxy knows where the NDES server is and how to forward that request. But we have to do something called configure an application. So I'm just going to click on that. And once I have done this, I'm going to explain what this is all about. So we are going to name this. Let's call this demo NDES. And then we have to provide the internal URL and the external URL. So the internal URL is going to be demo NDES. This is our internal URL, right? https demo.ndes or intune.com. We can just confirm it by going into the browser and making sure that it is working. Over here, you can see that if I go to the URL https demo.nds.intune.com, search serve mskip DLL, we get the 403 forbidden. So we are entering the same thing in the internal URL as well, which is https://demo.nds. Make sure that this URL is absolutely correct because this is very important. Now, the external URL is something that is generated automatically. Over here, you see that this is the external URL. I'm just going to copy this to the clipboard. In the pre-authentication, we are going to select pass-through because we don't want any authentication to happen by the proxy. We just want it to forward the request. And then the connector group is going to be the one that I have created, which is EAI connector group Asia. Now, what this is doing is any request which is coming to the external URL, which is https demo.nds nugget labs this, that is going to be forwarded to the internal URL by the app proxy. That is all the app proxy is doing. So the app proxy's job is anything that hits the external URL that is going to be forwarded to the internal URL. So it's like man in the middle. Now, this external URL is something that we are going to provide to all the devices in the internet. And how do we provide it to all the devices in the internet? This URL is going to be a part of the Intune profile, the SCEP profile, because the SCEP profile is going to be delivered to the device. And this device is, when it gets the SCEP profile, this URL is going to be a part of it. So just make sure you have this handy and just make sure this is correct, and the pre-authentication has to be set to pass through. All set. Let's click on create. Takes a couple of seconds for this to get created. It's not created yet, it is still creating it. Let's wait for this to be created, and once this is created, if we try to access this URL from the browser as well, our request is going to be forwarded to this URL. And we know what happens when we go to this URL. It gives us a 403 forbidden request. So we were able to see the 403 forbidden request internally in the intranet in the server. Now externally as well, we can access the NDES server over the internet by using the app proxy. Just wanted to make sure that the concept of using the app proxy is clear. Okay, so this is done. I can just click on close and close. And now our connector is ready. If you go to enterprise applications, you will be able to see that application over there as well. So we have named it demo NDES. So if I check with demo NDES, you can see that this is the application we just created with this name. Uh, uh, uh and then it tells you all the information that if you go to the application proxy blade, it will tell you the configuration that we have just done. Okay, now let's test it out. Now let's see whether our application proxy is working or not. How do you test that? There are two ways of testing that. First is we already have the external URL, right? You copy that external URL, you go to the browser and you paste it, and then let's press and enter. Now the expectation is if the proxy is working fine, this should forward the request to the internal URL that we have provided, which is this. And what happens when we go to the internal URL? It gives us this 403 forbidden error. So the expectation is that the request from here should be forwarded to here in the IIS of the NDES server, and we should get the same message that we are seeing internally. So right now I am in my host machine. This is not the NDES server. This is my host machine present on the internet. So I press and enter. Yeah, there you go. We see the 403 forbidden error as well. So right now, if you go to a mobile device as well, and from there also, if you try to access this URL, you will be able to get the 403 forbidden error request. So this shows that the my devices from the internet by using the app proxy are able to reach out to the IIS server. And now every time that happens, it gets logged in the IIS logs. So let me quickly open up the IIS logs. And if I expand this over here, you can see that there are a lot of hits. So every time I am going to that URL, it is getting logged in the IIS, and you see that the request is coming not from a device, but it is coming from a browser. So all set then, guys, now it's time for the moment of truth. And now we can go to the Intune portal and start with our demo. So first things first, let's go to tenant administration and let's make sure that our connector is still active. And I'm at the Intune portal. Side by side, I'm going to open up the Azure portal as well. And I'll be seeing the status of the app proxy connector. So a connector and tokens and certificate connectors. My connector looks good. I have an option of renaming this as well. So if I have renamed NDES1 and NDES2, I have an option of renaming this. So if I click on this, I am going to rename this to NDES demo, so that I know that which connector and in turn which server we are talking about. So NDES, I have named this NDES demo because this connector is running in the server named NDES demo. And the other one is named NDES2 and NDES1, which are powered off because they are running in the server named NDES2 and NDES1. Okay, all good. And now let's take a look over the app proxy. So I'm going to go to Azure Active Directory and then very quickly going to go to application proxies, and my application proxy demo NDES is online. All right, all good. So now we can go to the Intune portal and we can start making policies. So we are going to make a SCEP policy for Windows. So I go to Windows, I go to configuration profiles, and there are two profiles that we are going to make. So the platform is going to be Windows 10 and later. Profile time is going to be templates, and then the first one that we are going to make is trusted certificate. Let's click on create. So now I have to select the root certificate. Now we haven't got the root certificate yet. So the way to do that is, as we have seen in our theoretical section as well, we'll have to go to the domain controller, which in our case is the CA as well. And we have to run a command over there, which is going to generate this certificate for us. Certutil -ca dot cert c colon certificate dot cer. Just press enter. Over here it says that the certificate has been exported. So if I go into the C drive, I should have the certificate over there. So C drive, this is a certificate with the name certificate. You can name it whatever you want, right? So I'm just going to upload this certificate into the portal, and this is the trusted root certificate. So let me just show it to you guys again. If I just double click and open this certificate, if I go to the certification path, it only has Intune DCC. This is the name of the CA, and this has been issued by the CA and issued to the CA, valid for 5 years. Okay, this is the root certificate which all the devices must have so that they can trust any client or server authentication certificate. So back at the portal over here, I'm going to browse to the location, and this is the root certificate, and just next. And then I'm going to do the assignment later on. Right now you see that the certificate has been uploaded. Just next, no applicability rules. I'm not assigning it right now. I'll assign it later. Right now I just want to create the profiles. Okay, and there you go. The profile has been created. Now I'm going to create the second profile. This is going to be the SCEP profile. So the platform is Windows 10. I'm going to select templates, and the one that we are going to create is the SCEP certificate. Let's click on create. And now we are going to configure the settings. We can assign a SCEP profile to a user or to a device. If it's a userless device, then we'll have to assign it to a device only. That would be the only option. That if it is a user-based device, that is there is an active user attributed to the device, then we have an option of either assigning it to a user or a device. I'm going to select user. In the subject name format, the document, if you read the documentation, it will tell us the different subject names that we can have. The subject name means what is going to be the issued to for the certificate, and we can change it as per our need as long as the format is supported. So I want it to be provided to the user principal name. So the UPN is going to be the issued to parameter. And then we have the option of selecting the subject alternative name as well. Well, in my case, I just want the subject alternative name to be set to the user UPN. So I'm just going to select that, and over here the format, which is inside curly braces, the word user principal name. The validity, I'm going to set this to 1 year, which, or maybe we can set it to 6 months as well. Remember, our template has 1 year. So this has to be less than or equal to what our template has. It cannot be more. Now the KSP, if your device has a TPM, then you have an option of enrolling to TPM, KSP if present, otherwise software KSP. We have a lot of options. I'm going to select, my device has a TPM, therefore I'm going to select that. The key usage, I'm going to select digital signature. In the key size bits, I'm going to select 2048 because my the template which is going to issue this certificate supports both. And the hash algorithm, I am going to select SHA-2. So far so good. Now this is the part wherein we link our SCEP profile with the trusted root. So after you have deployed the trusted root, you can make a SCEP profile. This is mandatory. If I click on this hyperlink, it shows me all the root profiles that have been created. I'm going to click on the one that is relevant, which is demo NDES trusted root certificate, and then just going to do a OK. Again, trusted root is needed for chain building. This is essential. Otherwise, my devices are not going to trust the SCEP profile. In the predefined values, my certificate is going to be used for client authentication. Therefore, I'm going to select that. The renewal threshold is 20%, and this is wherein I enter the SCEP URL. So this URL is going to be that of the Azure App Proxy. And this is my URL, the demo ndes-nuggetlabs.msappproxy.net. Search serve mscep.dll. Just refreshed it, just making sure it's still giving me 403 forbidden. It is. Now just going to paste this over here. Looks good, row added, everything looks good. Just going to do a next, and we are going to do the assignments later, and then we are just going to create it. So my profiles has been created. Let me just do a refresh. Now I can see the demo NDES certificate profile as well as a trusted root profile. So everything is set. All that needs to be done now is I need to enroll the device to Intune using a user. So let's do that very quickly. So I'm going to very quickly first create a group. Let's call this group demo, and I'm just going to add a member to it. The user that I'm going to use is named EPM. So I just select the user EPM, select, and then create. Okay, now you can see that my group is present with the name demo, and if I go into the members, I see that there is this member called EPM. Now let's go and enroll our devices. So let me open up the Hyper-V. Okay, so I'm in my client machine now. The name of the machine is Windows 11 Machine 2, and this device is not enrolled to Intune. So let's first do a Azure AD join of this machine and enroll it to Intune, and then we will deploy all the policies to the user who is enrolling it. So the device is now joined to Azure AD. So now I can log off from the device as I'm logged into it as a local user, and I'm going to sign into this machine as a Azure AD user. Okay, so just logged into this machine as an Azure AD user, and while this login happens, let's just go to the portal and do the deployment. Okay, I'm back at the portal here, and you can see there are these two policies. So first, I'm going to target the trusted root, and it is not assigned. So I'm going to go to the edit assignment, assign this, and I am going to assign this to the group called demo. And my user EPM is a part of it. Just going to click on select, save, and all good. Let me just duplicate this tab and go to the devices. As my device is enrolled, it will show up in the portal. Let me just run a sync for the device. Okay, so just ran a couple of things, and now if we come back to the portal, over here it says that the trusted root certificate is now successfully delivered. So it took about 5 or 10 minutes and the profile came down. So let's confirm this. So if I go into the MMC, but I don't see it over here. Why do we not see it over here? Well, let me just wait for 5 seconds and see and jog your guys' memory and see if you are able to answer. Well, we are not going to see the trusted root certificate over here, right? Because the trusted root certificate is going to be present under the trusted root certification authority. So if I go into the certificates folder over here, you can see all the root certificates that are present, and one of them is from my on-premise CA. So this is the trusted root certificate profile that I have deployed. It has come down to the device. So yeah, so far so good. Now let me go back to the portal and let us just take a look. So now this looks good. All that needs to be done now is in the configuration profile. Now the SCEP profile needs to be deployed. So let me just run a filter for demo. And this is my SCEP profile, demo and SCEP certificate profile. Everything looks good. Let me just copy the URL one more time and let me just paste it over here. Just making sure that my NDES is working and my app proxy is still working. Yes, it is 403 forbidden. Awesome. Everything else looks good. Let me just go to the assignments, edit, add group, and let's add the demo group. Adding the demo group over here. Come on. Select. Before I click on next, I just want to go to my NDES server. Everything looks good. Both the servers are up and running. Let me just minimize this. I have added the demo group over here. Just review and save and then assign. Now let's just go to devices and run a sync for the device. And let's just go to the device from the VM as well. And let's run a sync here. Just coming over here, going to info, scrolling down and running a sync. So let's just wait for a while and then the certificate should hopefully come down to the device, fingers crossed. Okay, so it's been about more than 10 minutes that we ran the sync. I just initiated the sync again. Now let us go to the device configuration profile and see what the status is. So Windows configuration profiles, let's run a search for demo. Uh, 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 Fingers crossed. And there you go. It shows as succeeded. If I click on view report, it says that the profile has been successfully deployed. Now let us quickly go to the server and the machine and see what the status is. Both of them are still active. And if you see the time, it's 4:32 a.m. right now. So it's been less than 15 minutes that the profile was deployed, and within 15 minutes the profile did come down. So let me quickly open up the, well, there are so many things I want to open up and see. The first things first, let's open up the MMC and then let's expand this personal certificates, and there you go. I see a certificate issued to EPM at the rate everything about intune.com and issued by the CA. Now let's leave this for a minute. Now let's go to the domain controller and see what's going on over here. So now I'm at the CA, and if I go into the issued certificates tab, the number 16 is the one that we have to look for. You see the requester is NDES SVC, but this is the service account. If you double click and open it, it shows that issued to EPM at the rate everything about intune.com. And if you scroll down, let's see the thumbprint. The thumbprint is ending with B9. Now let's match this with what we see in the device. This is the device. If I go into the details, if I see the thumbprint is ending with B9. Okay, so far so good, but let's track this from the NDES server. So the first thing I'm going to do is open up the event viewer log over here and then do a refresh. Okay, and I don't see anything in the debug, but I see a lot of stuff happening in the operational, and in the admin I see only one request. So every time a certificate is issued, there is only going to be one log over here. If I double click, it says that SCEP it says that successfully processed SCEP request, and if I scroll down over here, I can see the thumbprint as well ending with B9. This is the thumbprint of the certificate as well as the subject name, which is EPM. at the rate everythingaboutintune.com. Now let's go to the operational logs and let's see all the processing. So these are the three logs that we have already seen: 4003, 4004, 406, 4008. So let's see 4003 first. Now this is the first log that comes in which says that successfully received the SCEP request. So this is when the CSR is coming to the device. Now after the CSR has come, the next one is 4004, which says that successfully verified SCEP request. So this is when the Intune service did the validation and informed back the NDES server that the CSR has, that the challenge has now been validated. After this, the NDES server reached out to the CA and the CA issued the certificate. Therefore, it says that successfully issued the certificate for SCEP request. And then the last one, which says that successfully notified Intune of the result of SCEP request. So again, bringing up our flow over here, we see all the four logs which run in correspondence with the Intune's the CSR coming to the device. We see the first log for that. The second log is when the Intune is telling the policy module that yes, I have verified. That is for step 12. And then when the CA is issuing the certificate and it's telling the NDES, that is step 14, we see a log for that. And when the NDES is informing the Intune service, that is on step 16, we see a log for that as well. So all those four logs as per the flow can be seen over here. And if we go and check the IIS logs, we'll be able to see a request from the device coming to the IIS logs as well. So if I open this, you see that all these requests were for the browser, but there was one request for the device as well. Okay, now let's go back to the portal and see what's going on over here. Okay, the next thing that I wanted to show you guys is the monitor section. And then under certificates, you can see that there are two certificates that are issued to the EPM user. And it tells you the subject name, the key usage, the EKU, when was this issued, and the name of the device and all of that. And just a little while later, now you see that in the device name, we find Win11 machine 2, the machine that was targeted by the policy as well. So it takes a while for the report to show the information, but over here you see that this is the machine, this is the username, and the same certificate ending, the thumbprint ending with BEE9, and the serial number, subject name, issue, and all the other relevant information as well. So this takes a while to get updated, but from that section we can see all the certificates that has been issued by my NDES server. So as far as deployment and tracking is concerned, that is pretty much it. I mean, we were able to track the devices response. We were able to see in the IAS logs as well. The get CA cert, get CA caps was there. We did not see the sync ML, but well, obviously the profile was deployed to the device. That's why it showed up. What we can also see is if we go to the device, we can see the device installing that certificate. Probably that is also one thing to look at. But we know for sure that since the certificate is showing up over here, the certificate is surely installed. But for parity's sake, let's see that as well. So device management, enterprise diagnostic provider, if I go into the admin, over here you will be able to see the logs that are responsible for installation of the certificate. We already know the event ID, so I'm not going to waste a lot of time and then directly just see that. We have to look for the event ID 309 and then 39. So let's directly look for that. So let's just put in a filter current log and the event ID is 309. And there you go. At 4:29, the local time, right now it is 4:46. So around 15-20 minutes back, the device had received the certificate. Over here you can see that at 4:29:06. And then there will be another log which is showing that the successful installation of certificate also happened. So that's pretty much all I had in the demo section. And if you have been patient enough throughout the entire Nugget, then I just wanted to let you know that I am always reachable for any questions. If you might have any, please feel free to reach out to me in LinkedIn or reach out to me in WhatsApp as well. The number is mentioned. Now, this is not any attempt at doing any promotion. I just want to make sure that you guys have a resource or you guys have a platform if you have any questions related to any of the nuggets that I'm doing. But that's pretty much it, guys. I hope that in this session we were able to understand the background of SCEP, why exactly SCEP is needed, the 1,000 feet overview, as well as a granular understanding of how exactly SCEP is working at the background, the relevant logs, registries, the setup that is needed, and in the demo we were able to see all of this in action. So I hope this has been informative for you. I would like to thank you for viewing. This is your friend Saurabh Sarkar signing off.